Hello. Alright guys, so give it a couple more minutes before we start doing anything. But I'm gonna be building a set of PVS-69 ALPHA. It's got this cool spray paint job to it. Tried to mimic multicam, use some stickers, and ended up breaking it, and so I epoxied this piece back on, which is why that's on there right now. Not sure what the problem is there, but you might not be familiar with 3MF files, but that might have been the problem. The 3MFs were in there. But I'm gonna be posting it. Boost volume? No clue. Sorry, dude. I'm gonna be posting the files later tonight. I'll just speak up. How about that? I'm gonna be posting the files for everything in a bit. I'm gonna do STL format for everything because some of y'all ain't caught on that 3MF is the future. So, getting on the frickin' bandwagon already. Yeah, so, well, not really sure what to talk about here, but, questions, comments, come on, guys. So, I guess I'll just, go over the alpha again. I think I've, touched on it a million times, but, there's still, a lot of confusion out there. And I want to make this, as less confusing as possible. So, the alpha, this is the alpha housing right here, all these printed parts. That is a digital or analog housing. It works with both. To make it work with both, you need the MX69, which is a printed tube. Here's one part of it right here. And the MX69 is a digital intensifier tube in the same format as a regular intensifier tube. So I'll actually pull one out to show you guys what I'm talking about. This is a really fucked up tube I got from someone on the Discord server who's a champ and came in hot and let me pick this tube up off him for a cheap price. The tube itself is pretty much fucking toast, but it's a functioning tube. You just can't really see out of it. So I'm just going to show you guys a comparison of the alpha tube, or not the alpha, the MX69 tube and an actual 10160. So right here we have a MX 10160. Here's our positive contact, and the whole tube is a ground. And then here's our MX69. They're the exact same diameter. They have the same alignment pin. The sensor is obviously a lot smaller than it is on a tube. But yeah, they're interchangeable. The MX69 might be a little longer with that screen poking out, but it really doesn't make a difference because you can just adjust the eyepiece to make it fit. But yeah, both of these will fit in the alpha housing just fine. Both of these use a PVS-14 eyepiece. This right here is a PVS-14 eyepiece. It's the lens cell, which is this buddy, and that comes out of a regular eyepiece, and then we print the housing that has a bigger thread on it to thread onto these better, because the standard thread is fucking tiny. So yeah, that's kind of the difference there. It uses the same eyepiece, but it uses the different objective lenses. So this is a PVS-14 objective lens. It will not work with the MX69. These are expensive as shit, so don't waste your money on them if you're planning on doing a digital build, because you'll put this on here and you'll be like freaking telescope Superman. You know, it still works technically, but it's gonna be like so retarded zoomed in that you'd think you're like trying to snipe somebody. All right, let me just put my MX-69 back in its housing. Where was I going? Oh, and here's the objective lens for the MX-69. There's a printed shoulder on it. This is the CS mount 8mm lens. Back in 9, did some, what is it called? Fucking tests against them, comparisons against the M16 8mm lenses. I don't know why the fuck my Discord is like beeping like that, but I'll just shut the TV out. Anyways, this is the objective lens for digital. It's got a printed shoulder on it, an O-ring, and then this part is just the retaining collar that tightens up right here, and it smushes everything into the tube and makes it fit. There's an extra piece that goes on here. Don't have one laying around to show you, but that just like pushes on there, and some M3 grub screws, and it just makes that bigger. And so you can grab it, and you can also put like PVS-14 sacrificial lenses on there, and like daylight caps or whatever if you want to, but it's kind of just a waste of money in my opinion, because with the digital you don't need daylight caps. All right, so before we go over any of the hardware bits, let's go over the printed parts, and I'll address specifically what I got here. I got here, these are printed in PLA Plus. I don't remember the brand, probably Overture, but printed in PLA Plus. These parts right here these are printed in a carbon fiber PLA. I just literally printed these out quick for this tutorial. This is that printed shoulder for that digital objective lens. So this just goes on here, and it's super snug fit, but you just push it on there till the ring is flush with the threads, and make sure it's nice and square all the way around, because that's going to be your square surface the lens pushes against. But also, this is that piece I was talking about that makes it bigger. And then we have our pods. These are alpha pods. They're I do have like MDF or MJF versions, but I fucked them up and I lost like the proper file that I actually ordered them in, and then I ordered some of the wrong ones, and yeah, so the MJF shit's a mess right now, but there's going to be MJF files available, so you can just order them from like a US based like print shop that does MJF, or they might work for SLS too, but I'm not sure what the tolerance difference is between those. Oh fuck, this one's broke. Whatever. I must have broke it at some point. Anyways, there's going to be some MJF SLS files available at some point, so you don't have to get those strictly from me. Let's see. We got this right here is the TPU button. This one is actually a powdered TPU print. I ordered a bunch of these. I want to order like a shit ton more, so that way I can include them in the Alpha hardware kit, because if you order these from a print house, they take a long ass time, because I've only found one place that prints powdered TPU in the US, and that's Jaws Techs. If you guys know anybody else who does it, let me know. But Jaws Tech does the TPU buttons, but they just take a long ass time, like a couple weeks just for that little piece, because they don't run, like obviously they don't run TPU all the time. Here's the bridge with a dovetail on it. I had the dovetail on it when I painted it, but yeah, I snapped this little sucker off, and then I just like epoxied it, and I also pushed this brass washer on there and let that get epoxied in place, and then put the bolt and the nut on there, just to hold everything tight while that epoxy sets, so I can use it for this tutorial / live stream. I'll do a dedicated tutorial at some point, but that's pretty much all the printed parts. Here's the front plate. I think I said this before, but this front plate and like this PCB with the switch and TPU button should be compatible with older versions of the PVS-69. So like the, do I have one here? This should be able to replace that front load bridge file. So this should be able to go on the front and all the dimensions should be the same. The only problem is this doesn't have those two bottom holes, whereas the other bridge does. So you could like fill them in on that bridge or drill holes on here if you want to make this one work. Sorry. All right, so that's all the printed parts. I'm just gonna slide these over here for now. And we'll talk about the hardware. This isn't all the hardware. Some of it's like really tiny, so I got it in the box still. But you'll need 4 of these bolts. Obviously, there's one right there. You'll need 4 of these. These bolts are M3 by 40 millimeter. I'm experimenting with these ones, which are like a countersunk head, and they actually seem to work really well. And they're like literally the perfect length because they're just a bit shorter than these like button head ones or whatever you call these ones, socket head ones. They're just a little bit shorter. But with these ones, I've actually found that like if you tighten it too much, it'll shear into the print and it'll come right through. But for some reason with the countersink ones, you can really crank them down and they don't go into the print. I think the head might be a little larger on the countersunk ones. Yeah, I think the head's a little bit larger. That might play into it, but who knows. You'd think that this one would be able to pull through easier. But so 3 of these M3 by 40s. I think the link broke that I put up for these washers because now it's linking to like plastic washers. But these are a M8 brass washer. They're 8 millimeter inner diameter, and I want to say 16 millimeter outer diameter. But we'll just double check that right here. Yeah, they're like a 16 millimeter outer diameter, and they're 1.3 millimeters thick. So you can find those somewhere else. They'll work. But I think the link I posted had broke. So, or they are out of stock or unavailable or whatever. This isn't included in the kit. I just have these, so I'm going to use them. These are just some scraps of the 8 millimeter brass tube from the 69 Gen 3. And basically, if you just have like 10 millimeter section of this, you can pop it in here. Actually, I'm not going to press with that with my finger because I gave myself one of these. Pressed on it, cut my finger. But you can pop it right into the end of this, and then it'll also support that hinge. Which housing are you talking about? If you're talking about the Gen 3, I'd have to get back to you on that. I don't remember the bolt sizes for that. But yeah, anyways, these are just some scraps of brass tubing. And yeah, so I'm going to be using them for this. But they're not going to be included in the kit. If you have them, use them. But what you can do actually is you can use a 5.56 shell. You can just cut some sections of that and probably heat it up and kind of sink it into the plastic a little bit. So what we have here actually, this is something new. It's not something I intended to put in the kit, but I'm going to be. This is actually 2 things. It is a Nylock M3 nut and a like conical washer. Let me get some fresh ones for you. So these conical washers, they're an M3 cone washer, and the nut kind of went in there backwards, which is like the only way I could get it to fit. And it gives it like a really nice look. You'll see when it's done. But then these are the just M3 Nylock nuts. They got that nylon on them to prevent them from just sliding off the other way. But you put them in upside down, so the nylon's actually inside of it, and it works really good. And as you tighten it down, it like pulls the nut into the washer. But yeah, you'll need four washers and 4 nuts. Right here is a latching push button switch and this is just going to be the switch for the board. These things are rated to like 10,000 cycles, so they should be good for your project, but they're super cheap, so if you break them, it's not that bad to replace. They're only like maybe 10 cents, but the problem is you got to buy like 50 of them at a time. There's a couple of these M3 heat sets, and then for the IPD bolts, I'm just using a couple M3 by 12s, and depending on what your IPD is, you can go longer or shorter with those, but M3 by 12 works for me. And then this bolt is like an M3 by 5. It's probably way too short, so I'm probably gonna have to step this one up. But actually M3 by 5 fits this, I forgot, yeah. So M3 by 5 drops in here, and you tighten that in. And that bolt doesn't actually hold the dovetail to it. It just stops it from sliding back and forth. What holds the dovetail is this double dovetail joint. So the dovetail actually can't pull out. It has to slide out. And that's like obviously by design, but that's just a way to strengthen up that joint right there, so not everything is hanging on that one bolt. It's not gonna be like midnight tonight, but it's gonna be tonight. I just gotta get to it after this live stream. So whenever we're done here, I'm gonna go compile everything and do some last minute editing, and then put it out. So we also got these alpha PCBs, and this one right here is the regulated bridge board, and it takes a 3.3 volt Pololu buck. Yeah, that's just what it is, and it solders on to the PCB. Last time I tried this on live stream, I spent like 45 minutes just soldering this piece and didn't get to work and ended the live stream. But we're gonna get it this time because I got the trick now. Right here, these are the tube boards. So the tube board is something that I'm trying to implement on the Gen 3 and the Alpha platform. And basically what it is a multi-use PCB. And eventually when I get around to like an RNVG type, I'm also gonna use these boards for that. But basically, you obviously cut it right here in the middle, and that's one board. One side's positive, one side's negative. And if you're running this in your Gen 3 setup, that middle pin is going to be your high voltage, and you're going to like solder some springs on that. And the boards in the Gen 3, you'll need more of these boards because you have to put one in the tip, one in the tube on each side, so you need 4 of them. For the Alpha, you only need 2, but it's just easier for me, and I guess it's easier for everybody else too if it's all just the same PCB since the dimensions are the same. So in the Alpha, you'll just ignore these middle pins. They don't do anything. Yeah, I think that's pretty much it. There's some in here. They're super tiny. Wait, not these ones. These are way too tiny. I don't know where I put them. Oh, right here. I got these springs right here, and these are just a leaf type spring for the circuit board. They're super tiny, but so I'm not gonna take those out because they're not like cheap, but it just sucks to have to order them. You gotta pay for shipping and stuff when that happens. Yeah, so that's pretty much all the hardware parts. I'm gonna go ahead and throw everything into this bin right here, so I don't lose shit, and I'll just pull it out as I need during the tutorial / live stream. First things first, I'm going to go ahead and set the heat sets. Actually, I'm gonna leave this for a little while. I'm gonna start off with this thing. I know last time I fucked this up like royally, but I got it figured out now. I know what to do. So my iron's already hot. I'm gonna just like hold it onto this board and get everything nice and hot, and crank the iron temp all the way up this time. My solder glue. Alright, I'm gonna get a little solder on these pads and tennerize them a little bit. I think that's the term for it. What I'm doing is I'm globbing like way too much solder on there, so that way when I actually like press the board on, it goes just fine. But I'm gonna keep it like ridiculously hot, and I'm gonna press this board on there. That's hot. All right, I think we got it. That'd be pretty crazy. First try. Yep, pretty sure that's a solid joint right there. Obviously those two pads are connected, so I'm gonna go ahead and suck some solder off of those. But other than that, I think that board is on there. We're gonna run a continuity test. Once I pull some of that solder off, find my fucking sucker machine. Sucky. Alright. Here's the old sucky machine. Go ahead and reheat this solder right here. Check the comments, see if anybody said anything crazy. I have like some kind of flux stuff, but I don't know what it is really, because it's not really flux. It's like pretends to be flux. They call it solder paste on the package, but it's yeah, it doesn't really do anything. All right, those look like they're all separate now. We'll go ahead and continuity test. And what we want to make sure is we want to test that the board doesn't have continuity across these pins. So I'll slide this into view. There's going to be like resistance across them, but not continuity. And then we want to make sure the bottom has continuity to the bottom pin of the actual buck. So we're touching like the pinhole, not the solder on the board. Make sure the top, so this top one is the ground right here. Sorry, this one up here is the ground. This is the voltage out. So this is the positive out. And we want to make sure the middle pin on the buck has continuity to the ground pad. And then up here, there's some solder mat or silk screen to show you that this is the ground up here. And then we have continuity there too. This is just a buck, not a buck boost. So I'm actually looking into doing something with a buck boost because I've heard you can get some like more efficiency out of some batteries with that, but it's controversial. So and then we're going to test our positive in is making contact with the board. So it's not showing contact, but oh, duh. Okay, it's not making contact because we don't have the fucking switch in. I'm an idiot. Once we have the switch in, we'll test that. But there we go. First try. We got the buck on. And now we're going to go ahead and solder on the switch. So what I do for the switch is I'll just bend these tabs over. It's like this. And then you can slot them into those holes right there. And then actually you're going to push your switch so it's flush with the board and kind of centered as best you can get it. And it'll hold itself in place pretty well and while we solder those on. But you want to make sure that button is centered in there. You don't want it cocked off to one side. but make sure it's flush against the board, and those tabs will slot into tabs in the PCB, but they won't pass through it because that buck is on the other side. So we'll just go ahead and throw a little solder on the edges. You also don't want to get these switches way too hot because they can travel, the heat will travel up into the switch and like melt the switch apart. I haven't done it building a set of alphas, but I did it tinkering with these switches on other projects where I actually just like the switch fell apart because I got those terminals so hot. I'm gonna turn my iron back down. Let's see. Is there a Zener diode? I don't know. I don't know if there's one on this board or not. I really don't know what is on the board. I'm fairly certain Polulu says that this board is reverse voltage and short circuit protected. So probably, but I can't say for certain. All right, just reading some comments there, guys. So here we go. We got our buck soldered on. We got our switch in now, so we'll test continuity from the positive in to the actual like voltage in on the buck. So here we go. Got contact, switch the switch, and nothing. Good. That's exactly what we want. We also want to make sure there isn't contact from ground to voltage in. Got contact on ground, then there's no contact from ground to voltage out. I don't plan on running this with more than 4 volt input, so it's safe for both digital and analog if this buck were to fail. But I would just recommend not to, if you're going to build this, you should also build the 69 battery pack. You can get everything you need for the battery pack off my web store for $15. So it's like the power source. There's a battery pack that's 4 volt or 3 volt, it says, because that's for CR123s or 18650s, or you can get the 6 volt one, and that's for the Gen 3s, but the 3 volt one is for the alphas. So that's what I would recommend for that, because it could save you a lot of money, because I did have a buck fail, not a Polulu buck, it was like a 10-cent Amazon buck. Had it fail, and it destroyed a freaking Gen 3 intensifier tube that had like a super tiny blem. So I'll do a video on the battery pack, but it literally takes 5 minutes to build, and it's like a first grader could do it. I'll probably just build one on live just to show you. But here we go, we got that soldered up. Now, find my helping hands. That guy wandered off too. Here he is. And what I'm gonna do first, I'm gonna split these circuit boards. So, I think there's a better way to do up the tube PCBs so they're easier to snap apart. But what I do is I just have it like this. And the reason it's 4mm fucking piece right there is because JLC PCB, who I originally was going to order these from, required it, and then I just haven't changed it since I've been ordering through Polulu, or not Polulu, through Osh Park, because it's also important to note that like some of this stuff may fall under ITAR, so you don't want to order from outside manufacturers outside the US. There is a parts kit on the site for the Gen 4, so that's up there. Yeah. Now I'm gonna clean this up with just this probably. That's probably good enough. This stuff sands down super easy, so a couple scrapes on the file. You want to try and keep them square. Don't get them too out of square. And don't sand them down too much past those points, because you just don't want to do that. I don't know what I'm doing with sandpaper. I literally just took a sanding bit off the blade. Alright, yeah, so just clean those things up, so those aren't going to be an issue, those spikes or whatever. We're going to test fit this into the bridge to make sure that fits tight. Alright, it's pretty tight, a little bit of side-to-side movement, but that's going to get screwed in. And then we'll test fit these into the tube. And if you look at it, when I say front of this board, I'm talking about these double pad side. That's the front. That's the side that the contacts are going to go on. And when it's in the tube, it's going to be like this in there. The contacts are going to go towards the eyepiece side of the tube. But yeah, we're going to test fit this in there and make sure it goes into place. And if it doesn't, just take a little bit off the edges of it. But it snaps nicely into place and sits. So you'll see that it sits below flush. That's what you want. You want it below flush with the edge, if you can even see that. Yeah, below flush is what you're looking for there. We'll go ahead and test the other board in the other tube, keeping the double-sided one towards the eyepiece. Oh, and look at that. I tried those tree supports that Prusa has now. Everybody loves them on Kira, but the fucking shit takes forever to clean up. I prefer to just have my supports be a solid chunk and then, take that solid chunk out instead of fighting with a million tiny pieces. I can show you in the eyepieces too, like that sucked. Cleaning those things out sucked. because I print really hot, so my plastic tends to like be pretty homogeneous, if that's the word. Boom, there we go. Below flush in there. It's kind of like at a weird angle. It's not sitting fully where it needs to be in the front, but I think it'll be fine. So those circuit boards fit. We're not going to tighten this one in here yet. We are going to toss our TPU button in there and set our board in there. We'll hold it in and we'll test it out. Let me give that another test. And I did sit and click this thing for like hours one night, and it failed one time, and I'm not sure exactly what happened, but it just stopped clicking, and then it like started clicking like a minute later after just like pressing on it and fucking with it. Something must have got stuck. I'm not sure what got stuck where, but something got stuck and it wasn't like clicking down, and it was stuck in the off position. So take that like how you want, but yeah. Another thing I found too is these brass washers. You build these, dog. You build these. So these brass washers actually fit in on that TPU button nice, and they rest on like the shoulder of this switch. So if you want to like throw a brass washer in there to stiffen it up, it definitely stiffens the whole system up quite a bit. So if you want to do that, you can, but you don't have to or need to. But like the brass washer kind of sits and rests there, and it just stiffens that button up quite a bit. But the difference is negligible. It's just an option and something that I like thought was kind of interesting. Yeah, so what now? Oh, now we're going to solder the contacts onto these tube boards. So I'm going to go ahead and poke them out. I'm just going to come in from the top, push down on the board, drop the board out. I'm going to do them one at a time so I remember what board fit what tube. The way I like to do these, I haven't done like a ton of them. Obviously, it's pretty new design, but the way I've been doing it is just like this. I'll take my helping hands. I have some heat shrink on his jaws so he doesn't scratch the boards up, but I'll kind of set it up at a bit of an angle, leaning that way, so I can set the contact here and just put some solder, and it'll like kind of flow into exactly where it needs to be. So it's super, I'm gonna say it's super easy, and then I'm gonna just totally bone it, but it's been a super easy process. I'm gonna flip the magnifier over so I can see what the fuck's going on, and then y'all probably won't be able to see this super well, but I'll be able to see it, which is what matters. Oh, my back hurts. Now I'm gonna like get it kind of lined up as best I can on there. Oh, one thing to note, for this spring, have the angled side towards the front. So pointing towards the eyepiece, you want the angled side. So that way when you slide your tube in there, it doesn't hit a nice ridge. It just hits that angle, compresses it, and slides over it. If you're doing the pogos, because you can use pogos in here, it's not what I'm putting in the kit, but it's in the parts list if you want to use it, because they do work and they're cheap and you can get them on Amazon. If you're using these tiny little pogo pins, it's quite a bit harder to put the tube in, but what I do is I shim it with a piece of a pop can, and I'll go in from this side and I'll hold the pop can in place, compressing those pogos while I push the tube in, and then I'll move my finger obviously once it hits past those pins, finish putting the tube in, and then I'll pull the pop can out. And that's how I do the pogos. But getting it out is another story, because you can't really fit that shim back in there to do that. But yeah, I recommend doing these leaf springs. The parts kit has them. It is important to note that eventually I'm going to be doing away with the regulated boards in the parts kits. As soon as I run out of stock of these, then I'm switching over. But the parts kits are also going to be a lot cheaper because these boards right now are $10 a piece. But if you're running the battery pack, the 3-volt battery pack, you don't even need the board anyways. So that's why I'm going to be doing away with those. Oh, fuck. Should grab some tweezers. You see, the contact is like turned a little bit, so I'm gonna try and straighten it out. I'm wondering if I didn't fuck up the whole contact at some point. Did I twist this one? No. It's not going on straight for whatever reason. All right, there we go. Contact is on there. Pretty solid. If you're trying to solder these yourself, try not to get too much solder in the hinge of the contact. It just reduces its actual like hinge workload capacity, like the amount that it can spring. So try to keep the solder on the board and on the very bottom of the contact. And then I'm gonna jig it up for the other side. Obviously you want the contacts on the same side of the board. Don't get them mixed up. Don't solder one on the wrong side, because I haven't done that, but I can foresee somebody doing that, because anything that can go wrong will go wrong. Alright, there's contact number 2 soldered in place. And we're gonna pop this one. I'll just set it in the tube off to the side. Ooh, that's hot as shit. And then I'll pop the other board out. Jig it up. Slide it back into frame for y'all, and we'll solder that one up too. You don't need like a whole ton of solder for these, just enough to make them stick to the board and make like a decent solder joint. You also don't need to be very good at soldering for this project, because most of it is board soldering, and since I'm a novice at board soldering, I tried to make everything as novice friendly as possible. That was hot as fuck, sorry. So like the holes are all oversized, so no like trying to fit the wires in the hole and then like one single strand doesn't go in, and then you're like fighting that one strand and then 10 others come out, and yeah, the holes are oversized, so you should be able to like put the wire in there and there's plenty of room. So I tried to make this as easy as possible. I'm going to straighten that one out with the pick, and that one should be on there too. Hot as fuck. I don't really want to touch it, but I do gotta look at it. It's not super straight on there. This is going to be the positive contact, so I'm going to straighten this one out because that one's important that you get correctly. There's not a whole lot of room to play there, and if you get it off a little bit, then you're going to be shorting. So yeah, I'm just going to reheat this one up and just move it. I don't need to add, I'll do a little more solder to like help it remelt, but oh my gosh, it's going crazy. All right, there we go. That's pretty straight. Boom, there we go. There's two tube PCBs soldered in, and now what we're gonna do is take some wire, and what I like to do is, this is red wire, doesn't say what gauge. I want to say this is a way smaller gauge than one of those. This is like 26 gauge silicone coated wire. The silicone does cut pretty easy, but I'm going to show you the trick that I've been doing to get around that cutting. And you don't need much of this, so give yourself enough to work with, but don't just like be wasting a ton, because you only need like maybe like 3 inches. But I do like 5, and use the handy dandy teeth strippers, and we're going to, oh, where the fuck did the boards go? There's one. Where'd the other one go? Oh, here it is. All right, so when you're looking at the board, you're looking at the eyepiece side. We're always going to like look at everything from the eyepiece side. Positive is always going to be on the right. So there's a pass-through hole right there. And what you're going to do is you're going to pass the wire through the pass-through hole. You can take a big loop. You don't need to do a small loop right now. You're going to loop it back through. And I like to push it as tight as I can against there. And then I'm going to clamp the wire into this coated like jaws right here, and then I'm going to adjust it. So it's like that, and we're going to solder that wire into that pad right there. And remember, positive is always on the right, and that's talking from the eyepiece orientation. And then we're soldered up. So I'm gonna go ahead and clip off all this excess. And then you can pull this lead through. You want it to kind of compress against the board and be pretty flat down, but not totally flat. But the reason you want that casing all the way up in there is you don't want like a strand or something poking out and touching the tube, because on the 10160, the whole body is a ground, so the positive has like a short potential there if you have like some stray strands coming out. But since these holes are really oversized, where actually like the entire casing can fit through a plated hole, maybe not on this wire, but the holes are pretty oversized, so you shouldn't have any like stray strands. You can like pre-solder it before you slide it in the hole to avoid that as well. And I got some black wire. I'm just gonna cut a couple inches. That was probably definitely not enough. It's gonna be a pain in the ass later, but whatever. Alright, so what I meant by like pre-soldering these is I'm gonna just stick this right here, and I twisted it like how you'd normally just like twist up a wire when you strip it, but I'm gonna get a little solder on the tip. I'm just gonna like rub it on the wire, and that should like hold all those strands as a single piece and not let them like fray out. And then looking at it from the front, we're gonna pass it through that side hole over there. Do the same exact thing we did on the other side, and we're gonna push that casing as much as we can up in there. And I like to keep like a loop on the bottom because it prevents it from like pulling itself out. But I just put those there into the jaws, and then we're gonna solder up that wire right there. Alright, so we get that one on there, and then got a lot of extra solder on there, so I'm just going to clip everything. Clip all that off as best you can, and then pull the wire through. And this one's not as critical about the strays because the ground pad is so huge, so if you're grounding on it, you're just making extra contact. But there's one, and we're going to do set this aside with its housing, and we're going to do the other one. Yeah, hit like on the main post. Do what that guy says. So what I like to do, because this is the silicone wire and it's like kind of easy to cut it, like they're super easy to like strip with your teeth, which is probably not like a good thing to do, but I do it anyways. I like to put some paracord like casing on it, and that helps prevent like cutting of the wire or like pinching of it, because even silicone wire, like even pinching it can kind of rip the casing. The benefit is it's super flexible, but it's very non-abrasion resistant, so it does cut pretty easily, cut and tear. But I'll show you how I do the paracord too, because somebody told me that trick. I don't remember who. Somebody told it to me. I tried it, and I was like, wow, this is freaking awesome. I'm going to do this on everything, because it really does help, like a lot. And then I'm going to cut off any excess that's poking through. And then, like I said before, positive is always going to be on the right when you're facing eyepiece side. So just keep it right, wire it right. Do your pass through. The pass through isn't like 100% necessary, but it prevents the wire from easily being pulled out if you poorly soldered it. So I'd recommend it. Just do it. It's like an extra thing that makes it nicer and more robust. And we like busty things. All right. Look, that's hot. Did you guys know that soldering is actually like very hot? Hot enough to burn you if you touch it. All right, now we're gonna do the paracord. Let me find some paracord sleeving. I know I got some. I'll be right back. Alright, so I just went and grabbed a little bit of paracord, pulled the internal out of it, and we don't need a lot of this, we only need like an inch. I'm just going to singe the ends a little bit, but not mush them, because we still need to run shit through it. I just don't want it to fray a bunch. We only need like an inch of this, so don't do more than an inch, trust me, because it's not going to be better, it's going to be worse. So we got our 1-inch section cut. Meh, we don't have to worry about lead. Come on, man. What is lead? Lead is metal. Metal is hard. Metal makes us strong. Yeah, like I said, just cut off an inch of this. Don't do more than an inch because it makes it worse. Boom, a couple 1-inch sections, and then some heat shrink. You don't have to do the heat shrink, but it makes it look cool, even though no one's ever gonna see it. It's just like one of those things, you know. There's no reason not to do it. So grab a couple sections of heat shrink. Don't know what size they are. I think it says 4mm on it. It's out of a Harbor Freight heat shrink multi-pack. And what I'm gonna do, I'm gonna cut these in half, each section. So we don't need a ton of it, we just need a little tiny bit, but we do need all of it. And then we're going to take our heat shrink. Actually, I like to do this with my heat shrink. I stretch it out a little bit to make things easier, but it still shrinks to the same size. It just is nicer if it's stretched out. The paracord will like fit in it better, and any frays will get caught up in there. It's just a little bit nicer. So we're gonna put our heat shrink all the way down. Take our paracord, the less frayed side. We'll run our paracord in there. I'm gonna press that into the heat shrink. Just like that. And then we'll stretch out another piece of heat shrink. Actually, you know what? We're not going to use another piece. That's plenty right there. And I think that'll be too much abrasion resistance if we do another piece of heat shrink on there. But we'll shrink this, make it nice and tight. Kind of pinch it down, make sure it's not going to go anywhere. It did wander away from the board a little bit, but that's fine. I'm going to just roast those fuzzes on there and get it nice and small and tight. Boom, we have a nice little abrasion resistant piece. So that'll be enough to pass through the hinge and into the bridge a little bit and past that 3mm bolt that'll be passing through, but it won't be too much that it stops the it'll be just enough is all I'm saying. It's just enough right there. About 1 inch of paracord is just enough. So don't do too more, don't do too less. And I'm just going to stretch out another piece. Oh, this ground wire is tiny, but it's enough, but it's small enough that it's going to suck. Ah, man. I really don't want to switch it out right now, but I know I should. Alright, fuck it. I'm gonna switch out that ground wire because it is kind of short. You want like 4 inches minimum, 5 inches maximum of wire, and this is more like 3, so that's gonna be a pain in the dick. And we don't like dick pain. So what I'm gonna do is I'm just gonna put the wire in the jaws. I'm gonna heat it up. I'm gonna pull it away from the board and hope a lot of the solder gets pulled with it. All right, that didn't happen. So if you make a mistake, this is where the handy dander solder sucker comes in. You just heat up one side. Try and get the solder nice and hot so the sucker can pull a lot of it off. Oh, this one is on its way out the door for sure, so it doesn't have the same pull as a brand new sucker. That's probably all the suction we're getting out of that thing. All right, so here's what we got. We got a nice hole that we can work with that hole. Got our new section of wire. Strip it. Run it through the pass-through. Shit is hot. And run our wire up through there. Getting some stray wires on there. And then we'll pull this kind of tight. Chalk her up in the old helping hands. Laying down on the job. And we'll fucking solder that bitch on there. Boom, we're soldered on. Crisis averted. Clip off any excess. Pull it through. There we go. Now we'll go ahead and drop our gapped out heat shrink on there. Throw on the old paracord sleeve. Get it into the heat shrink. Push it up tight. Remember, if it moves away, it's not a big deal, but you want it tight. Where'd the damn lighter go? Heat up the heat shrink. Pinch it a little bit. And there we go. This side's already pretty burnt up, but just crisp her up a little more. The silicone wire is pretty heat resistant, so you don't have to worry about like melting it, but it's very like not cut resistant. Just taking a pause to read through some comments, see what y'all are saying, and apparently not shit, so chat up these comments, guys. Come on, blow this thing up. Make it viral. Make it viral. Yeah, I don't really care. I have no desire to be a content creator for YouTube. I just want to make some dope ass night vision for you guys. Oh, I gotta stretch. Oh, I don't know if y'all heard that on camera. My fucking back just popped. Alright, so we got our two PCBs soldered up, and we can go ahead and pass these through. Yeah, I think this is 26. It doesn't say on the container, but I'm fairly certain I remember ordering 26 gauge. The holes are pretty oversized, so you could work with something smaller, or something bigger. But 26 gauge is nice because it fits past that M3 bolt. Damn it. They're like different lengths, and it's like one of them's catching on a little stray print strand in there, so it's not fucking pushing through. Get your dumb ass in there. Alright, I'm gonna cut these the same length. The wires go in. You can go in from the eyepiece side, and you want the wires to come out of the pod on the objective side, because that's where they pass through the bridge. Oh no, there they are. Don't lose them. Fuck, man. The hardest part's getting the fucking wires in, apparently. Alright. Fuck it. Sacrificial heat shrink. Pin these fuckers together so they can't get away. Let's do the same to the other one right now. Oh, one wire's way longer on this one too. A wheelchair with tracks. Well, that sounds pretty cool. Alright. Now those fucking wires won't be all just being stupid bullshitters. So we'll just stick those up in there. There's like a damn, I don't even know what that is. It's just like stray print material in there that's like stuck in there. I think it's part of the freaking tree supports, those fucking things. I can see where tree supports would be cool on like the Glock 19s or something that you're printing. But if you're printing one of those, but they kind of were not super cool for this. Yeah, so the Chinese eyepieces, where is one? I just had one. These are the Chinese eyepieces. Let's see. Here's a filter. Boom. You see that? I'm not going to link to these filters because they're knockoffs of Low Light Innovations filters, and those guys have helped me out a lot with this project, so I don't want to like take their business away from them. But you can get the Chinese filters, but you can also get filters from Low Light. I don't think they have green ones because nobody filters green to green or white to green, but they have the purple filters and stuff. It's a pretty fun project. This is the Alpha. If you're not familiar with it, it's brand new. It's literally just being released today. What's the bridge question? Let me check the chat. If you have the Gen 3 and you want to run the alphas on it, probably just the bridge body. It's a lot shorter. This is like basically a redesign of the front load bridge, but it's a lot shorter because this distance is tighter. Oh, you can't do that. I don't have anything currently to make that work. It's possible. Let me see. Here's the Gen 4 or Gen 3 bridge, Gen 4 tube. You would need to have some significant spacers in there. Yeah, you could probably just like extrude this piece out. I don't know what the actual number would be, but maybe like 10 millimeters, 5 mil. You'd have to experiment with it, but you could extrude this piece out, and that would work on there. But I don't know how the wiring would go because this took that 3-position switch, and this would have 6 volts internally because the wiring. So you'd have to like still do all the regulator stuff from the Gen 3 where you program the buck or whatever, dial in the buck on the Gen 3 one. It would be not impossible, but different, and not something I'm trying to explore, but something that could be done. All right. Another thing to note is make sure when you're installing these, the springs are going towards the eyepiece. That's just the way they go in there. So make sure you get that right. And the boards can get in there crooked, and it'll just like not sit right, and you'll wonder what's going on. It's because the board's crooked. But the way it should fit in there is nice and tight. You should see both pins when you're looking at it like this, but the board shouldn't be protruding. I have one of those FMA bodies, and in my opinion, it's not worth the effort because I've taken it apart. There's no hollow area to pass any wires through here. Everything that makes the LED turn on is on a board that sits right here. There's a big magnet right there that turns those LEDs on, but it's just not something worth chasing down, in my opinion, because although it's cool, the FMA body is pretty significantly different from an actual 31. So it's like you get that 31 look, but still not the same thing as a 31. You'd have to figure out a switch because this is just a knob that does nothing. It's held in by a screw. The battery cap does come off, but it's kind of a pain to get off because that rubber, this like rubber lanyard piece keeps like resetting it. But I just don't think it's something worth chasing down. I do plan to bring back the battery bridge, but it's going to look something more like, if you've seen the katanas, I think they look kind of crazy because it seems like the battery sits like way in front. I plan on doing something with the battery in the center still, but I think I could balance that out more and not have the battery like protruding. You know what I mean? I don't know. If you look at the katanas, you'll see what I mean. The battery like protrudes super far, and I don't think that's a good setup. But, shit, where are we at now? All right. Now we're at the bridge part. So what I'm going to do is I'm going to take, where'd my little parts bin go? Alright, I'm gonna take this brass tubing right here. I'm gonna make sure it fits in the bridge. Doesn't really fit. I found that like a flathead screwdriver works pretty good for just twisting in there. There's probably just spray paint and shit in there clogging it up. So the brass tubing will fit. You just want it to be able to go into the bridge. I might have gapped that one out way too much. I did cut the shit out of my freaking finger earlier on this brass tubing, so just be careful with it if you're doing this route. Boom. Alright, so the brass tubing, what I'm going to do is I'm actually going to epoxy it in place in the tube. So I'm going to grab some gloves because I hate having epoxy on my hands, and I got the nice cut on my finger. Alright, so went and grabbed a little container to mix shit in. Went and grabbed a little scrap of filament to mix it with. And actually, you know what? I'm not gonna epoxy this in. I'm gonna try something new. I have this potting compound, which I was gonna use in the last live stream on that MX-69. This is in a black epoxy-based potting compound. I've never used it before, but I bought it and couldn't return it, so might as well try and use it. It's got a little mixing injector, and basically what I like to do is I like to push epoxy down in here, but the way I've been doing it is mixing up 2-part epoxy, using a syringe, sucking it up and putting it in there like drop by drop. But I'm just gonna try this thing because hopefully this works and it'll make my life a lot easier. All right, boom. Damn, is it really just that easy? All right, so I'm gonna go ahead and squirt some epoxy down in there. I don't really know how much to put in there. Oh, that shit comes out hard. All right. Ooh, there's so much of it. Oh my gosh, this was so messy. It's very liquidy. All right, looks like it takes about a pump. Oh fuck, it's pouring all over the place. Where did that fucking container go? Alright, this was a terrible idea. I was not prepared for this. Sorry, Palmetto State sticker. Oh my gosh, this shit's so goopy. Oh my gosh, it's pouring out of that one too. Alright, I just made a fucking mess on my table. Whoops. Alright, we're gonna push that brass in there. Make sure we have that wire kind of tight. And then, should we just fucking squirt some more in there? Actually, you know what? I'm gonna wait till I got like shit pushed up into the bridge. Yeah, fuck the PSA sticker. I got so many of those. Alright, damn it. Sorry, I was taking a second to read comments. What I don't want to have happen is have it run into the chamber where the tube sits. So I kind of want to keep them vertical, but it's fucking leaking out like crazy. So that sucks, but it is what it is. Push that brass in there. Doesn't want to sit level. There we go. Wait. Nope. Ah, damn. Print stuff in there. It's important that that brass gets set in there properly, or else it's not going to hinge right. I'm gonna go ahead and throw the washers on there now, and maybe that'll help keep the brass straight. Shout out to Jonathan, who just bought some raffle tickets. Hope you win, dude. Good luck. Oh no, there's epoxy everywhere. This was such a terrible idea to use that thing. It squirted out way more than I thought it was gonna. Oh my god, it fucked everything up. Alright, that was a terrible idea, guys. I'm gonna have to figure out a better system for that, because it's like all over the objective lens threads, which I plan on keeping this a digital housing anyway, so those aren't that big of a deal. But it was so much more watery than I expected it to be. Damn, it's like all over the table. I think I have a fucking napkin from my pizza earlier. I guess it cleans up alright. I don't know how long it takes to cure. I didn't even read the instructions. 70 minutes. Well, that sucks. That's a long fucking time. I should just went with the 2-part epoxy. Alright. I kind of messed up my paint job a little bit, but it is what it is. I think the best thing to do right now is to get this fucker on there so that epoxy stops running out. So on the MJF file, it's going to be a little different, and there's actually, instead of like a peg that comes out and sticks in, it's going to be like the back of the tube is going to be more blocked off, and there's going to be like a small peg that kind of comes out, but the hinge is going to rely mostly on the like actual bolt itself that passes through, as well as the brass washer in there. So I'm hoping that I can get this that part in the tubes to like plug them so it stops oozing everywhere, because that was a mess. That was not expected, and it's probably gonna like bond it to it, which is gonna suck, but whatever. Adds to the camo, kinda, yeah, I guess. Alright, yeah. It's like oozed everywhere, so it's probably gonna like epoxy into a fucking solid piece, but it is what it is. Just snap it. This isn't like a high strength epoxy, it's a potting compound epoxy, so hopefully it's not like strong and like fights me. Alright, that was kind of a mess and totally unexpected. But we're gonna let this cure for a little bit. And instead of going ahead and get the soldering, we're going to talk about the eyepiece cleanup. Dude, it takes 70 minutes, so I'm not going to move them for 70 minutes. I'll move them closer to when it's dry. And yeah, so we're gonna talk about eyepiece cleanup. So the way I actually made the file, I made this wall a bit thicker, and you're gonna have to sand it down. I should have talked about this way earlier in the video actually, but basically what I do, ah fuck, trying to be comfortable. Where's my fucking drill? Oh my god. Give me a sec to do something. Oh, my back hurts so bad. Where the fuck is my drill? Alright, so I take a socket. This is a 22 millimeter socket. I put it on my impact. And then what I normally do is take one of the housings that I'm going to be using. Obviously, I can't really do that with this one, but I have some electrical tape wrapped in that socket to make this a nice snug fit. And it's not like threading into anything, it's just snug on there. And then I tighten this eyepiece on here. And then I go ahead and I sand this a little bit to make it smooth, and so it doesn't have a whole lot of friction to it. Let me find some sandpaper. And we'll go ahead and just sand this. I'm gonna move this epoxy gun. I'm gonna take the tip off it and put a cap back on too. I don't know what I did with it. Alright, we're capped off now. No more leaky. Go ahead and slide the PSA sticker thing out of the way. Fuck, that sticker's a mess. Yeah, could use silicone. Silicone's also a fucking mess. The way I was doing it before is not messy, not like this. So this was new. It's just like running everywhere inside. Oh, this board's not even like in place anymore. I don't even know how that happened. Pull on the wire, get it kind of set. That brass tube's not sitting straight, so that's gonna suck. It's not gonna be proper. This was just a mess. Should not have turned out like that. Classic live stream, right? Alright, boom. I'm gonna take these gloves off now because I'm not gonna be fucking with epoxy for a bit. Alright, back to this. So we're just gonna sand this up. It'll work, I'm sure it will. It's just not ideal. So you really want this to be smooth. You can keep the metal ring from your eyepiece, or you can use a printed one. It's up to you. The printed one's a little beefier and it just looks better, but the metal one grabs better. But I like to make it small enough that the metal one goes on there with little friction. So you don't want a lot of friction on this, but you don't want it to be like free spinning. But once you get the metal one on there, then you're about to size. Where's a lens cell? I know I had one sitting around. All right, then we got our PVS-14 lens cell. There's a little bit of fitment that needs to go with this too. So it looks like we're not quite at the inner diameter we need to be. So we need to sand a little bit on the inner diameter of this. But also I like to take a square file and I'll run this square file through here and just clean up any like stray print material that like poked out. And it doesn't take a lot, like that's enough cleanup for that. And then you just, there's only 3 of these, so you just clean up whatever's there. I'm gonna chalk this back up and we'll sand off the rest of it. To sand the inside, I'm just gonna fold the sandpaper up like this. There's something in this tube. Oh, there's a fucking MX-69 piece in that tube. Just sand that inner bore until we can get the PVS-14 eyepiece to, you want this one to be pretty frictionless. If there's too much friction, it's going to be too hard to adjust your diopter because there's also friction on this O-ring that's in the tube, and that's where you really want the friction to be. So you want this fit to be pretty much frictionless. Good up here, but it's not good in here. So this is what I was talking about with those tree supports. Like all this little bitty interface material is just impossible to get out of there. It's just not coming out. Let's see. I'm gonna go ahead. I'm gonna file these grooves a little bit because I think that support material is blocking the tube. There we go. And also that Z seam might be playing a factor here because you can see the seam right there. So what I'm gonna do is I'm gonna take the Dremel. I'm just gonna like buzz that seam a little bit. Make sure there's no like high spots in there. Looks like there's a high spot right here. I would definitely set your seams to aligned when printing this part. Because that way if you have to do any Dremel work, you're not like Dremel here, Dremel there, you know, jumping around. You can just buzz a line to get rid of that seam. But let's see, that's what do we got holding us up here? We're just gonna run this back and forth a little bit. So just push it here and push it here. You want it to be pretty much frictionless, like I said. I don't really want to push on the lens, but it is what it is. This eyepiece is Chinese, so it doesn't matter. Kind of got in crooked. All right, that's a pretty good fit. So we'll move on to the next eyepiece. We'll sand it inside and out. There's no such thing as a PVS-14 Tonto. That support material is fucking giving me a shit in the ass again. I tried to clean it up all before the live stream, but I should not have went with tree supports. Just Should have stuck with what I knew for this tutorial. Saved us some time. Alright. We weren't threading all the way on because there was some support material in the way last time. But we're just going to go ahead and sand this outside. Damn. How much in debt? Not really, actually. The raffle has really helped recover a lot of the costs. Had a couple dead tubes, lots and lots of rolls of filament that did not pan out in housings, whether it failed during print or there was just a minute difference. What really fucked me was Fusion 360. I do all the design work on my laptop, and then I print with my desktop, and Fusion wasn't like saving things when I would save it on my laptop and open it on my desktop. Like tiny little details that were very important weren't saved, and I would forget about them. And for some reason, when I opened it on my desktop, it like overwrit the save that was on my laptop, so I totally forgot about them. And then I just ended up chasing my tail like all the fucking place. A huge thing was getting that tube PCB at the right depth in the tube to make it actually work. Trying to show you guys how it's done. What got me into it was actually the BP NVGs. So I printed those. Well, actually, I saw it on TikTok, right? That's where I think a lot of us saw it. Is Coco made a video on TikTok. It was super famous, and everyone was like, "Wow, 3D printed freaking night vision! I want that." And so my birthday rolled around. I bought myself a printer and got really into like GunCAD, and I was printing a lot of like Glocks and ARs and stuff and testing materials and just like going crazy with it. I didn't know shit about printing at the time, so like my printer would break and I was just distraught because I had no clue how to fix it. But now I feel like I know more than most people about at least the Ender 5 series. Anyways, I printed the BP NVGs. I got them bootleg, as you should. I think he was still charging for the files at the time, and I like got some files for free and others not for free, and then I eventually like got them all, and I was printing them, and I like built a set, and I kind of just was not impressed with it. It was super heavy, and you couldn't really see out the sides very well, and I just kind of was like, well, this sucks, so I'm gonna build my own. And then I got started with the VP NVGs is what I call them. Now I refer to those as like a PVS-69 Gen 1, and because I built that into a quad system and a binocular system, and I knew there was a lot of improvement to be made, but I basically just wanted to make a lighter weight housing to be compatible with the BP NVGs, because I figured there would be some people out there who had the same concerns I did with the weight, and the angle in the Siamese pods was not very good, and the lenses weren't merged. I didn't come up with merged lensing. I think someone else did that. But what I did is I put the lenses literally touching in the housing, so there was less of that gap. That's how I got into it, and then I came out with the 69 Gen 2, which used the same Adafruit displays, but was like PVS-14 style and like threaded together. And this is a really good fit right here. Basically no friction in this at all. But yeah, anyways, that's how I got into it, and it's just kind of evolved from there. And now we got a freaking analog housing, battery packs, tons of dudes working on other things. Nax freaking laser is dope, and I really want to build one. I just don't have the time right now. But yeah, so I'm just testing the function of the threads right now. It's left-hand threads, so turning it tight pushes the lens in, turning it loose should pull it towards you if you don't unthread it too much. So looks like it works. Obviously there's no C-clip or anything to hold that on there, but boom, we got our eyepieces done. Now, hasn't really been 70 minutes, so I doubt this epoxy is dried, but we'll make sure everything's still in place. The PCBs look like they're hanging in there. Oh no, I forgot to put a brass washer on that. That would have sucked if it dried. All right, I'm gonna go ahead and drop a brass washer right here. Pinch that back on. Boom. There we go. Now we can talk about the bridge soldering. So should be super self-explanatory. It looks like I didn't fucking include solder mask telling you which is which. But the bottom pins are voltage out. These two top pins are ground. These empty holes on the side are pass-throughs. And these empty holes on the top screw the board to the bridge, and then these two are the positive in and negative in. Those two are marked at least, so it's something. It's not what we wanted, but it's something. All right, so one thing I think I forgot to mention at the start is we need some tiny screws. Now, I have a box of tiny screws. I just always lose the box of tiny screws. All right, so what I like to use is these, I guess these are M1.7 screws. I'll just go with the M1.7 by 6 because they're a little bit longer. And they're not going to poke through. They're just going to give us a little more bite. But you don't need to screw this in yet. I'm getting ahead of myself. That's what I'm doing. So without like fucking all this shit up, I wonder if we can finish the assembly. I'm gonna put gloves back on because that shit's messy. All right, so actually, I'm gonna let this dry for a little bit longer and talk about the battery pack. And I'll put together a board. I don't have a housing set to throw this into, but I'll show you how the boards go together. Super simple. Like I said, you can get this everything for the board for 15 bucks on my web store. That includes the PCBs, the 4 battery springs, the hell? Alright, there's 3, 4 PCBs, the 4 battery springs, and these pogo pins, which I'm not going to take out yet because they're fucking microscopic. I'm going to lose the gloves because that's just gay. Alright, so basically what we're going to do is I'm going to throw the saw blade back on the Dremel, and we're going to saw these boards up. What you have here is 3 separate boards all in one. So this is what's the mid board right here. This is called the mid board. We have our top PCB and our bottom PCB. And I updated the silk screen. These are the prototypes. I updated the silk screen on the final versions, which is what everyone's going to be getting. So everything's going to be marked out. These come in a 6 volt or a 3 volt. This one right here is 6 volt. So the only difference in building them is your negative out on the 6 volt is going to be the middle pin. That's the only difference. On the 3 volt, negative out is going to be this edge pin, and positive out is going to be this concave side pin. But the only difference is the 6 volt negative out is going to be the middle pin. And the way you can tell the difference is on the 3 volt pack, all these traces are connected across the bottom, and then they're connected to this one here. On the 6 volt, they're split because it's 2S, 2P setup. You can use these for 18650s or CR123s. You know, I actually had 3 people ask me in the same day the other day about Pan Bridge. If you want to panel bridge, a guy on the server, his name is Filthy Freak. Great name. He made a pod for the Gen 3 housing in the Gen 3 bridge. He made a pod that accepts intensifier tubes and PVS-14 lenses. You can pair his pods with the Gen 3 bridge and the plus 7 degree hinges that are floating around, and you'll have like a wider field of view analog system. It'll be kind of a hodgepodge, and you'll probably be the only person with one, but you can do it with that system. I'm gonna start looking at how I can make the Alphas panel bridge style. I don't like the idea of a fixed, like you flip it down and they're angled out and that's always how they're going to be. I don't like that idea. I would like to be able to rotate between the two. I haven't figured that out yet. I had the idea at one time to have like pods like this, right? And then you'd have a pinion gear in the middle and a like a rack on the top and a rack on the bottom. So if you swing a pod out, it would rotate the pinion gear and swing the other pod out. So you could have one-hand operation pano. So you could just like turn one and it would turn the other for you. I haven't brought that into fruition. I know there's another guy on Discord who has like a arcing pano bridge setup, which looks pretty dope. And I was trying to tell him to implement the rack and pinion system into his. I don't think he's going to do it, but his would be the perfect design to do it into because his like arc out instead of just like twisting. So that arcing motion is perfect for that rack and pinion setup. So let me read some comments. Cool. Would the DEET work in Pano? It potentially would. I'm going to talk about this for a sec. So thank you for bringing it up, because it's something that I'm trying to work on. Pano for analog is not easy, but it's not super hard. Here's like a trashed DEET system right here, but also you see that little brass contact there? I was figuring out how to make those, and I got a good update for that. Got this brass strip that I just put into a set of vice grips, bend it, snap it, and then it works for contact. Anyways, in panos, your tubes sit like this. So not, yeah, like this. So not super ideal for the DEETs, because you have this small screen, it's rectangle, and it's kind of like cockeyed, and you'll have another one that's kind of cockeyed the other direction, and you'll have like a V-shaped kind of display setup. It's not super ideal for that. I'm working on a special MX69 that brings the contacts onto the side. So when you put it in, at least the PVS-69 pano, you're gonna have squared up displays. I know Quack is working on kind of a cool idea. I'm not sure how it's really gonna come out into fruition, but Quack's idea basically puts two displays right next to each other. He's using the 0.39 inch, but it's pretty similar form factor to these. But he's putting his like this in there. So he thinks that you'll be able to look at him with the same lens. I don't think that's necessarily true. I don't think that's going to work out, just because of the way light, these like, not so much the PVS-14 lens, but these lenses need to be right up next to the screen to get a good image. And if you're using those like micro display lenses, they have really bad chromatic aberration, which basically means the colors, if you look at it from the side, the colors are like not where they need to be to form the proper image. So you'll see like a red image or a green image depending on the angle you're looking at it. If you're looking straight on, it looks fine, but if you're looking at it from an angle, it's got too much aberration and it doesn't work out. I think that's going to be the case with Quack's design, but hopefully it works out for him, so we'll see on that. But maybe he'll lay the displays flat and the lens will be able to capture both. That's actually possible. That might work. Let me just think about that for a sec. So if he lays out both displays, that might be in the view window of the lens, but it's probably going to catch a lot of edge warp, just based off of that quick measurement that I did. Anyways, back to the battery pack. We got our 4 springs. Those are going to go on the bottom. We have our mid board, and we have our top board. And the top board is going to take the pogo pins, and I'll show you how this all goes together. But what we also need is this, which this is included in the kit, so don't worry. This is a, I think this is 14 AWG solid core wire. I'm going to cut these long because I might end up using it in a full-size pack. But you'll need two strips of this solid core copper wire. And then we're going to completely strip the casing. Off the entire wire. And that's because the way it's passed through the battery pack, it's not really at risk of shorting. And I wanted to keep there to be as much plastic as possible in there and not have a big hole, to make the battery pack be slimmer yet the same strength. So yeah, just strip off all the casing on this 14 gauge solid core wire. strippers. You guys see my face? Is that ugly? IR LEDs and switch. So, actually, there is advice on that. Let me see. These are a board that Yukon designed a while back, and this is the 69 battery pack 1.1 board. And I guess there's a couple more like quality of life features that this board needed, and maybe 2 errors in it, but one of them wasn't his fault. But basically, this right here is equipped with 940 nanometer, or whatever the fuck NM stands for, IR LEDs, and this is a strobe circuit. So this actually will work in place of this board, even though it's not the exact profile. It will work in place of it, but it needs some editing to the actual battery pack file to make this work, and it does not let you pass a bolt through it, so you'd have to figure out a different way to attach the top of the battery pack. But these are the same distances and everything, so it will work. It just requires some modification. I don't think Yukon posted these files anywhere. He sent them to me. I ordered a couple of the boards, put them together, gave him my feedback on it, and I'm not sure if he's come up with anything new yet. I think he sent me something updated, but I haven't ordered it. But I plan to. I just hadn't done it. And then I just whipped these up quick and dirty because I was trying to practice my own PCB making skills and get that done. But, all right, so step 1, we're going to take this copper wire, and we're going to put it into the mid board, and we're just going to have a little bit sticking out. My helping hands. And the way I'm going to do this, let's see. I'm going to hang that wire in there, and I'm going to pull it till it's just about right there. I'm actually going to solder on the top side, but what you want to be careful of is not to get solder on the main pad area, because that actually isn't for solder. It's a contact area for the pogos, and I just made a giant pad area. But what we're going to do is we're going to solder this right here. There is for the alphas, and then for the battery pack, I'm going over it right now. This is everything for the battery pack is all on the web store. It's $15. Pretty freaking affordable for a nice battery system for your night vision. So all right, I'm not getting a good stick here on the copper wire. Damn. Ooh, that wire's fucking hot, man. Holy shit. Alright, that's fucking gay. I'm gonna use the solder sucker and pull that solder out of that freaking little thing. Alright, cleaned out. gonna do something different this time. I'm just gonna put it in there kind of a ways, and we'll see if that does anything different. Damn, the hole is just barely not big enough. What if we solder from the back side? That way it can't get away from us. What time alpha launch? Alpha launch after live stream. Alright, so here's what I'm going to do instead. I'm going to stick the copper wire, press it down into the board, and then I'm just going to throw some solder on the back side. That should hold it tight. I think the problem is this copper wire has to get hot enough to let the solder stick to it. I don't have the boards with LEDs like for sale. This was a project from a while back, like a few months ago, but it never really like came. Oh my god, that was hot. It never came into like fruition, I guess. It just was a thing, but never really became a public thing. I will follow up with Yukon after the live stream, and we'll see where his battery pack boards are at, and if that's something that can be published or not. Those are hot as shit. Alright, here we go. We got our 2 copper wires soldered up, and we don't want a lot of solder on those pads because that's where the pogos are going to contact. And we don't want too much solder in there because it can cause the top to tilt. Panos are coming. That's a future thing. I've talked about that a couple times, but you might not have been here for that. I posted some stuff on my Instagram for it. It's going to be pretty dope. So it'll be around one day. I'm going to adjust the camera a little bit to get myself more straight on here. Alright, so springs. I don't think it matters what way this board goes. So I'm just going to do it like this. Just make sure the springs are all on the same side. What I find easiest is to hold the spring in there with your thumb. It doesn't get hot on the end because it's a spring, but I'll like route some solder up around like this to touch it, and then I'll like run the iron on there. It's not fucking melting. So these holes on the battery pack board are actually pretty oversized for the spring. That's my bad. I'll try and address this in future boards to make it a tighter fit, because it really doesn't need to be that much bigger. But I just like press it in with my thumb as I'm soldering. That just gets it a nice flush solder on there. Some more solder on the iron. Nice little bubble. Let it just do its thing and fill in right there. Just hold pressure. Solder kind of fills in. Spring solid. almost dropped it on my dick. That one's not real solid. So, oh fuck, there's still liquid. That's funny. That sucks though, because it sealed itself up. Back to the solder sucker. Man. Unless I can just push this spring in. Alright, here's what we're gonna do. Heat the solder up from the back side and push the spring in. This tip is trashed because I left the iron on for like 16 hours. So it doesn't really work super good all over. Some of it's pretty charred and the tennerize is gone off of it. Alright, we're liquid. Now, without killing my fucking hand, push the spring in, pull the iron out. Ooh. Almost made the same mistake twice. Boom. That's what you're looking for. Nice ting, ting, ting. Solder on this beach. Nice ting ting. All right, so you notice that there's like little pegs sticking out. That's fine. You don't have to trim them off because there's space in the battery pack for them. I'm going to, but just keep in mind they fling off at like Mach 10,000 because it's like spring steel you're cutting, not wire. So these are probably going to end up in my foot in like a week. That one's probably going to be in my foot in tomorrow. That one, probably never. All right, there you go. We got these done. You don't have to like sand these up or anything, but you can if you want to. There's your bottom board. Now here's the top board. So it might seem like dumb that you're passing negative continuity up to the top when you don't really need to, but that is for a future thing, which will come, because I do plan to integrate the strobe. Oh, I'm putting these in backwards. Obviously the contact side for the battery is the shiny side. The springs need to go down so that their contact is on the same side. But I do plan to make a top PCB in this shape and format with the pass-through hole and the pogos and everything that has the strobe and a power switch to it. That's a thing. It's going to be coming. I just have to... my plan is not to solder on a strobe circuit like I did on those other boards. My plan is going to be to actually use that same circuit, remove the components, and solder those onto the board. So that way you can one-stop shop, get all the components on that board, but you remove them and you solder them on individually. This is the strobe board I'm talking about. There's not too many, but they're freaking tiny. There isn't a lot of room to put this board on here, is the problem. So that's my solution to fix it. So I'm going to have helping hands hold that, and I'm just going to put a little dab of solder on each piece. Don't put too much because there isn't too much clearance in the battery pack for it, but there's a little bit of clearance, so should be good. Where's the solder going, man? The most important pogo pins to get in are going to be the back ones if you have this board. But like I said, the strobe board is a future thing. And so if you plan on like one day just upgrading it, I would solder in the negative pins. And that's what we have there. I'm actually going to not touch them because that's bad. I'm going to take the Dremel and just Dremel these down a little bit. They're just a little bit too tall for my comfort, so just Dremel them down to make some more clearance. And then I'm gonna grab a battery pack body. I'm sure I got one. So here we have a body. How it's gonna work is you're gonna thread these. There's already a heat sink in this one, but you will need a heat sink. It's included in the kit, don't worry. M5 heat set. The knob is a little bit different. The issue with the knob is I bought some like pre-made M5 threaded knobs, but they didn't actually work. So I tried to make my own, and that kind of worked, but I don't think it's very strong. But I'll get to that once I'm done with this. Damn, yo. You're going to press your board in, and it's a snug fit for sure. This board is fragile. Don't press in the middle. Press on the ends. Oh, man. All right. I'm going to sand this a little bit. All right, sand that up a little bit so it should fit in there now. And it doesn't matter what way this goes in there because it's symmetric. Yep, this pack goes on the rear of your helmet. The way I've just been doing it is tucking it underneath the elastic of my like helmet cover, but I do want to like work out a better way because that's not super secure, but it is kind of secure, but probably not what you want. You can put Velcro on here. This is the old battery pack style, so it's actually like thinner than the top, but the new one, it's like the same thickness from the top pieces and the bottom pieces, so it doesn't like have this, so you'll be able to put Velcro right there. Cell phone style battery pack? No clue what you mean by that. Elaborate more, please. It seems like the tightness is on the ends. I'm not really sure why. This looks like it got a little mucked up right there in the print, so I'm gonna see if I can't just scrape this a little bit too. Could just be like elephant's foot in the board battery pack. Because I do print it this side down because that's more intricate to support than that is. And if the copper wire doesn't easily slide in those holes, you can just take some, what's it called? Fucking drill bit and drill it out. What the hell is going on? Ooh, I did not read that straight. Alright, fucking try now. It better fit this time. I'm gonna be upset. Here we go. Oh my gosh, what is going on? It's like not fitting by the corner. There we go. I'll just push it in there. A nice even push with the file. The file's a great tool. Damn, I was trying to read what you were saying. I'm just pressing it in. It's easier to press it close to my body. Sorry, guys. Oh, there we go. Damn. All right, what were you saying? A little battery pack that's same size as your phone to charge your phone. That could work, but whatever. I mean, I don't know. Depends on what the output is. Some people I think are using that. I don't personally want to use that, but yeah. You could use that if it outputs for the alpha. You don't want to put more than like 4 or 5 volts in there. 5 volts is like max, and I would not put that into your analog, but 4 volts is okay for analog because that's just like high voltage for the CR123, but I wouldn't want to run them too long at that because they're really rated for 2 to 3 volts. Analog tubes are. But if you're running off a battery charger, you're probably not running analog tubes. So you can run the digital off of 5 volts, which I think is usually what a cell phone charger is. Yeah, but so the way this kind of works is this PCB goes in here, goes onto that. I'm not sure if that's true. The bottom one is a nice tight fit into the bottom of the pack. Should fit flush. And then I might have some like spare parts. Alright, so I have some spare parts. Let's see what we got here. This looks like a top piece. Not sure why I threw this one in the junk pile, but there's the top piece right there. And you take your top board, you put it in there, and you can use some small screws to attach it. You can pour some epoxy, but also the board should fit very tightly in here. And it's not fully, or it is fully seated. It's fully seated. It's very tight. It's flush with most of it. But if you just put some epoxy in there behind that, you snap it in place. It's not going to go anywhere. You can secure it with the screws if you want to. So the battery pack. There's a Gen 3 voltage battery pack and an alpha voltage battery pack. The Gen 3 one is 6 volts. The alpha one is 3 volts. Yeah. So the reason these were in the junk pile is it has a rocking issue because that mid board doesn't sit deep enough, but that's corrected on the new files. That's also the reason you don't want to get solder on those pads, because then you'll get this rocking issue where you tighten it down and it'll rock because you're past the working length of those pogo pins essentially. For the bottom, we'll you can snip this wire flat or flush. It's copper, it cuts super easy. You can solder those up. And because this battery pack, like I mentioned, is the 6-volt one, you're going to use that middle pin as your 6-volt negative, and you're going to ignore this outer edged pin. This will also be a negative, but it'll be a negative for 3 volts, and it'll only be for those 2 batteries. This concave side, that's going to be your positive voltage. All this is going to be like well marked out on the PCBs that you guys will get. These are the prototype ones where I didn't even care about the solder mask because I understand what's going on based on the traces. So I didn't bother with the solder mask. I just wanted to order them. And somehow the fucking letters got printed backwards. I don't know how that happened. So instead of out, it says 2, but in reverse. Yeah, so what do I need to do to make this work? Oh, here's the bottom part. I don't have a good way to print this. I printed this one like this. Can't get the interface material off. That hole was undersized for what I needed, so I just ended up scrapping this one. But there's a nice dish in here to store some wire if you need it. But what I'm working on next is basically, this is the top, this is the bottom. The bottom, this is also a top, but I modified it because I wanted to use it on the bottom. I'm going to have the same DC jack setup, but the DC jack is going to get soldered directly to the board, and there's going to be like an area, we'll call it, that comes up right here, and that'll go on, and that'll be just a nice, snug, tight fit on that jack, and hopefully prevent any kind of leaking or anything like that, or any stuff like that. But the way this bottom part gets assembled on is you really want to just lather this whole interior in epoxy and just put it on. But with that DC jack soldered directly on, you can lather it all in there, put your jack on, lather some epoxy on that, lather epoxy in here, and then put this on, let it rest, and there you go. But anyways, to prove to you guys this is a battery pack, grab a couple CR or 18650s. You don't need all 4. You can use 2. If you do use 2, they're gonna have to be like this in the 6-volt pack. So 1 in the outside, 1 in the middle. In the 6-volt pack, if you're using less than the actual amount needed. So I know people say that like it's dangerous to put 18650s together if they're not the same voltage or whatever. I don't know, dude. Like, I didn't know it was dangerous until I was told it was dangerous, and I'd done it millions of times. So take from that what you will, I guess. But what the hell? Like I said, if you're using the outside as your negative, you're not going to get your 6 volts, and your battery pack's not going to work. So you have to use the middle pin as the negative. And this is outputting 8.2 volts, which if you have a Gen 3 build, 8.2 volts is safe for that, because you should have your buck in there in the bridge itself on the Gen 3 build. It's also safe to run that 8.3 volts into your alphas if you have the regulator in there, but I really don't recommend that because it's just something you shouldn't do. It's better to just have the 4-volt battery pack, which I have one right here. This is a 4-volt battery pack, all wired up. I didn't put that adapter piece on there. I didn't even epoxy this in place yet, but it's going to be a snug fit, just as snug as this, so that's pretty hard to get off of there. But yeah, this is the 4-volt battery pack right here. As you can see, the cap screw is basically a printed like piece on an M5 bolt. I don't remember the exact length. I want to say this is a 20 millimeter bolt, but it threads into the actual PCB, so it's like not easy to get out of there. You'll be able to get the cap off without losing the bolt. The bolt's not going to fall out, so it is still like retained. But this battery pack outputs 4 volts because the 18650s are fully charged, and I guess that's just what mine are outputting. So just to show you, you can see that we got our 4 volts, and 4 volts I would consider safe to run into that, but I do plan on doing CR123 battery pack for my personal set of NVGs. But yeah, so that's pretty much the battery pack setup. Now let's fucking get back at the Alpha build, the reason we're here. That battery pack didn't take too long, I hope everyone understood. It's pretty simple, easy to wire. That was the plan anyways. Let me crack my back quick. Oh man, I don't have a proper desk chair. You guys are gonna laugh. I'm gonna show you what I'm sitting on. I'm literally sitting on a storage bin with some like old uniforms fucking stacked on top of it. So that's my chair for this live stream, guys. My desk chair broke. Oh, this is killing my back though. All right. I think this epoxy's not quite set up yet, I guess, but it's gummy, so there's some pizza sauce in there. Let's see what we're gonna do. So we're gonna pop that heat shrink off that we put on there earlier. Take the circuit board out. You're gonna leave your button in there because you want that to stay in there. And we're gonna run our wires through and try and keep the positive on the bottom. Looks like I'm gonna have to clean that out a little bit, so I'm just gonna run a pick in there and just kind of make sure that the wires are gonna be able to pass through that area. It is like an overhang kind of area in there, and we'll run that in. They're catching right there, so I'll use the pick to lift them up. And when you are actually assembling these yourself, I do recommend having the pods like locked onto the bridge the way they are, because it just makes it more stable and easy to build. And you can, we'll say, uncouple them from the bridge when you need to. But that's not till like the next step per se. Also, if you're curious, I did do a written step-by-step guide on the battery pack, and it was only like 10 steps, so it's pretty simple to do the battery pack. I should clean the other side at the same time. Alright, just make sure the positive is kind of like on the bottom of the stack as you feed them in there, because it's going to go into the bottom hole, so it just makes it easier if they don't get all twisted up. If I had tweezers, that would be nice right now. Oh. Ask and they shall appear. Oh, shitty fucking tweezers. Oh my god, these things suck. They won't grab the wire. There you go. Alright, I'm gonna slide this dovetail off real quick. I'm pretty sure I just broke that shit again. Damn, that sucks. Alright. Now, you can do all your wiring right here into your bridge board. What you're gonna do is you're gonna run your pass through here, and then into the bottom hole. I'm gonna go ahead and teeth strip all these wires. Probably nasty because they've got epoxy on them, but ugh. Ugh. I'll just do those ones for now, and then twist them up a little bit. Oh my gosh, there's like trace amounts of epoxy on these wires from it dripping. It's just goopy all over my hands, sticky. All right, and the reason you want to like pass these wires through is because there's going to be slack, and that slack sucks when you're trying to assemble everything together. So it's best to do the pass through and then do your solder joint on the back side. I'm gonna hold this guy in place with the helping hands. Oh, nice. Dude must be drunk. Remember, positive goes on the bottom and negative goes on the top. Alright, there's one. Then we're going to run our negative through the hole. And then through the other hole. And it gets tight for sure, but it's not impossible to do. And you can leave yourself some extra slack, and that slack will get tucked in. I'm actually like soldering blind right now, just so you guys know, because ever since my eye surgery, I don't have close-up vision. So it's like super weird, and something to do with like I had implanted contact lenses, and something to do with that has caused like a not an issue, but basically solder is very shiny to me. I don't know what it is, but like when I look at solder, it's just so shiny that I can't see anything. That was nasty. That tasted so bad. Epoxy in my mouth. And I'm actually going to do something different this time that someone pitched to me. They said, hey, can't you pot the regulator in the bridge just in case it does get water in it, it doesn't fail? And I was like, wow, that's a super good idea. I had not thought of that. So when we're doing our final assembly, I'm going to squirt potting material all over that freaking regulator. Make sure it's nice and cozy in there. All right, I'm going to... Ah, it sucks. That piece, I epoxied this little thing back onto the bridge because I broke it. And it fucking broke back off. Damn broke back fucking mounting it. Alright, I'm just gonna run these both through and try and do it that way. It gets tight, like I said, it gets really tight in here. So it's good to have some extra wire. Mine were pretty short cuts, but so I'm running both through the pass-through and then back into their respective holes. And you certainly could just solder it from the front side if you wanted to. I'm probably going to do that for these ones because the wire is so short that I'm not getting a whole lot of room to be able to flip the board around even. So I'm just going to poke these wires back in where they go and solder them up. Fuck, man. This sucks. I'll just do one at a time. roll that guy over. And where the pass-through is kind of like optional in the tubes, it's not optional in here. Like if you don't do the pass-through, you're not going to be able to put this thing together because stuffing this, even this shortest bit of slack, stuffing that back into this little pocket here is impossible. Trust me, I've tried, and that's why I ended up literally drilling holes in the prototype boards that I had. Alright, I think we're solid there. Obviously the negative wasn't fucking solid. Cocksucker. I wonder if that tip is clogged up from that epoxy. I think I could reuse it. So I'm gonna pot the shit out of this board here. Damn. I do not have slack to be able to cut and restrip this. It like soldered the wire, but not the fucking wire to the board. So there's a clump of solder on the end. I don't want to have to cut that off. Oh, this sucks. I'm so tired. How long has this live stream been going? I don't even know what time it is. 158 minutes. Holy fuck. Some of y'all are dedicated, huh? Y'all really want to learn how to build these. I wonder how many of you guys are actually like AFK right now. You just want to support the stream, so you're here. Yeah, dude, I really was not kidding. You kind of need it. This was super short. Normally there's like a nice inch or two of extra wire here that you can, you basically like pull it through and that tightens this up for when you put your bridge on. This one's got plenty of extra. The other one doesn't. Oh, dude, that's what's going on. That sucks. The fucking damn board PCB popped out of place. I want to get epoxy all over my hands. I don't even know how that happened. The tube PCB like came out of place. It was so solid in there. What can I do? This is I ordered a fucking aluminum MX69s and the house altered the fucking file. So, they just printed me one solid piece and sent it to me. And I was like, wow, this is totally useless. So, thanks guys. Wasting my fucking money. But, I did end up getting a refund on those, which was kind of cool. Because that was pretty fucking annoying. So I was like, yo, what the hell? Like, I know there was a significant gap here. And then they finally, like, fessed up that they fucking changed the file to make it easier for them to print. Let's see. I know I got, like, something else I can wedge in the other one. I'm gonna wedge this one in there to keep the other board in place, hopefully. Ugh. It's not gross. Damn, I'm gonna push that out. I do not like the way that went in there. Fuck, man. looks fine. Let me grab another one of these aluminum 69s. Tried to cut it on my mill, didn't work. Kind of like broke the mill, so my mill's broken. That's cool. Yeah, it probably would. Probably would have worked better than this. I was trying to experiment with some potting compound, and I regret it now. Yeah. What do I do with that fucking nozzle? I throw that son of a bitch away. Here's our potting compound nozzle. Now, what we're going to do is we're going to pull our shit tight so our board can go flush in there. Make sure your TPU button is installed. You can install it through the front with the powder TPU button because it's relatively squishy, but it's going to be very hard with a printed TPU button. Now we're going to put some screws in. And don't worry, because these screws aren't the only thing that holds the board in. Actually, the, what's it called? The bridge kind of has a, pushes against the board to keep the board in place. Oh, there's like dog hair attached to my freaking fingers now and everything. It's a mess. This epoxy was a terrible idea. I should just use the regular stuff. And worse, it's like black, so it's like makes my hands look like they're all dirty and greasy, but they're not. I got yelled at work before for having grease on my hands, but it was spray paint. Nobody believed me. Just making sure I get these screws extra tight, get that board in there solid. All right, now we got kind of this thingamabobber set up right now. Sucks that that piece broke back off. If you know what I'm talking about, this broke off when I was fucking around with it right after I painted it, and I was like, ah, damn, I tried to epoxy it back on, and the epoxy did not stick, so that sucks. But it is what it is. We move on. Let's talk about a DC jack. This is obviously another bridge prototype. See, it's got 4 holes. I did away with that. But it's got a jack with some leads soldered on it, so I'm going to steal these. There is a couple different types of DC jacks on the market. I've only really found one that's actually, or 2 that have any kind of IP rating to them, meaning they're waterproof. So let's see. I got a couple up here that I could probably show as examples. I got no fucking clue where they're at. So I got these ones, which I like these ones because they have a nut that goes on the outside, making them easy as fuck to install because the nut goes on the outside. But they're not have any kind of IP rating at all. You can see right through them actually. Like if you shine a light on this end, you can see it inside here. So there's no IP rating to them. But you know what? Since we're already fucking messy with epoxy and all fucked up on drugs and whatever the fuck else, let's send it. So it looks like this hole's a little undersized for that. I'm just going to take this sucker. Yeah. We'll just gap it a little bit, you know what I'm saying? That's how we like to do it. From the inside. Alright, sweet. So now this jack's gonna fit in there. And should be able to push it all the way down. Alright, boom. Barely any threads stick out, but it is what it is. This is gonna make our life easy though. So what I'm gonna do is I'm gonna do a quick continuity test on this, figure out what terminals go to where. The middle pin is gonna be positive, so basically I just wanna figure out, I think there's 2 grounds on this. I just wanna figure out which one's the positive on it. So what we got? What? No way. Is that actually the freaking... What the hell? Oh, dude, this makes no sense. I'm on continuity. Alright, touch the center pin. I have a feeling it's this middle leg. It's positive, so I'm gonna hook that there and see what happens. Alright, either this jack is broken or I'm retarded. Wait, we got something. What do we got? Alright, these 2 are the negatives, and this is the positive. Don't ask me why. I'm going to bend the positive one a little bit so we know which one's that. Alright, don't need a lot of wire for this, just a little bit. First thing I'm going to do is solder it to the board. I'm going to do about 3 inches. When you're looking at your board, it's marked negative on the left, positive on the right. Trying to keep with the theme here where positive is always on the right. I'm going to let the bare wire kind of poke out a little bit so that way I can get some solder across this whole joint and into the wire. Oops. Motherfucker. Oh, I dropped my damn solder. Well, that looks like it worked. Well, we're losing people, guys. We're only down to 28 now. Who here's been from the start? Hey, Nicholas, if you're still here. This is both digital and analog. All right, we got our wires on there. Yeah, no, it's like not just the build process. The entire thing is exactly the same. It's literally exactly the same. Here's the digital tube. You build the digital tube. It's a little bit different, but the housing is exactly the same. 30 minutes before it started. Holy man, you're in it to win it. Speaking of in it to win it, you win the raffle? Because that'd be pretty dope if you won that. That's a pretty freaking sick set of night vision. I was really contemplating not doing the raffle on it, but since I'm like unveiling the alpha right now, that raffle just seemed like the right thing to do, you know what I mean? Someone's going to be very happy when they get a freaking set of dual tube night vision with Carson lenses for like $10. Like, come on, dude. Like, you know how stoked they're going to be? That's crazy. The last guy who won the last raffle, I don't know what happened, but the shipping company broke his fucking nods. So I'm going to send him, like, he wants to do the repairs himself, so I'm going to send him the stuff to fix them. But, like, that's pretty shitty. Like, I don't know what the fuck happened, but I sent 3 sets out from the same UPS store, and they broke all 3. I don't know what they did, but they broke them all. They, like, snapped one pair, one side didn't work on the other one, and the other one it just didn't work at all. So, fuck UPS, because that's, like, the only time I ever shipped through them. I shipped 3 sets of nods, all in Pelican cases, and all 3 arrived just destroyed. So, it's pretty shitty. But, I don't think I have to have both negatives connected to this wire, so I'm not gonna. I'll do a nice classic teeth strip. Dude, they might be. You never know. They're in cahoots. Alright, let's see, it's not small enough. Got some real small shrink tube. I keep this shit on a roll. It's just like 2mm, I think. This stuff is the most handy to have around because it's like for single wires, single small gauge wires, that is. But I have a super bad habit of forgetting to put shrink tube on. I do it all the time and it sucks. But what I'm also going to do on this specific jack, because I'm already just getting sloppy with the fucking potting compound, I'm going to also pot this jack. You ever seen that before? Probably not. So I'm going to cut a piece of shrink tube that's like about the size, and will this fit over this end? Doesn't necessarily fit, but we can make it fit. If you ever need to resize shrink tube, snap ring pliers work great. Boom, resized shrink tube, and it'll still shrink back down to that mini size that it needed to be. All right, so we're gonna solder on positive. I'm just gonna pass the wire through, and then I don't want to hold it with my hand because that sucks, but I'm gonna grab that right there with the helping hands, and I'm just gonna fucking solder this wire on, throw the shrink tube on it. I'm gonna straighten this out a little bit. Boom. I don't know what that middle one is. It might be like a mounting hole pin, but either way, I'm avoiding it like the plague. Boom, soldered. Now would probably be a good time to test everything before we fucking just send it. So, what I'm gonna do is take the fucking aluminum tubes out of there. Actually, wait a second. Yeah, Maybe I shouldn't take the aluminum tubes out of there. Let me see. I'm going to continuity test everything real quick. See if that aluminum tube provides continuity. And no continuity. Hey, shout out to Augusta. Got his raffle tickets. Wait, we had something. We had a resistance value. We have a resistance value of 1.9 ohms. That could be provided by these aluminum tubes, but who knows. So we're going to pop them out. What we really want to do is continuity across the pins. So we're going to continuity across the two positives, which got nice and sloppy with potting compound, which is not super good for their performance. We got continuity across the positives and continuity across the negatives. Continuity from tube ground to outside ground. That says yes to me. Alright, continuity from tube ground to outside ground. Now we need to know, oh my god, my back. We got continuity from tube positive to outside positive. This one's not going to beep, it's going to give me a resistance value because of that buck converter. Oh my gosh, this is a sloppy mess. Alright, let's see. Fuck, man. It just keeps moving like further and further away. Alright, I'm not seeing anything on there, but it's whatever, because I'm just going to do a voltage test now. So, let me grab a little battery setup I got. This is just a CR123 and a little battery tray with a janky ass setup. I'm gonna plug this son bitch in. Hopefully nobody dies. And by nobody, I mean that fucking buck, because that thing's $10 and it's gonna be a pain to remove. Now we'll check our, not continuity, but our voltage. So we got 0 volts. We'll click the button. And we've got fucking still 0 volts. What I don't like is there's so much potting compound that got on those contacts. That's gay. Wait, it actually could just be this battery pack. That thing sucks. We'll do this one. 4 volts, 18650. Should be seeing 3 volts on these terminals still. How do you guys like that? Do you like it? Can you hear me? I'm whispering in your ears. Yo, I'm not getting any fucking voltage. The problem is they got so much potting compound on them that I'm not sure if it's making a really good connection. I'll check the other side, but they both should be pretty solid fits. Oh my gosh, my back hurts. Let me start with checking the jack, because that would rule out square one. What? We got 1 volt on the jack. Not sure how that's possible. Zero volts on the jack, 1 volt. I think these pins got so fucking epoxied up. The actual pins of the fucking voltmeter. I'm gonna wipe these things off with some alcohol real quick. We'll see what it reads now. I'm only getting 2 volts at the jack for whatever reason. What happens if I power it off? Maybe a release today. Alright, what the fuck is going on here? Ooh, ow. Why is it so hot? Battery pack. Battery packs say 3 volt, but I also short battery pack just now and burned my hand. The fuck? What does this cable say? Cables say 3.9. Okay, now Radio USA. Let's see. It's not getting warm. This pin says, what? Do both grounds have to be connected? That'd be weird and not make much sense. I have no clue what's going on right now. I think this jack is like fucked because I'm getting no voltage at the jack. That's gay as fuck. I'm so tired of shit being gay. Tired of gay people being gay too. Fuck those guys. It's not warm, it's not getting hot, it's not shorting. It's just not working. Shitty fucking Amazon jacks, yo. For some reason, I'm only getting 1 volt out of the jack. Oh, I don't want to redo this. Oh, wow. Hold up. Does anybody know if epoxy is like electrically conductive? I'm gonna look that up real quick because it just went buzz buzz and was very hot. So I wonder if this epoxy is like conducting across those pins or wires and like shorting it out, like doing the opposite of what potting compound should do. Okay, that's dried epoxy maybe, but is wet epoxy like that? Well, this is potting compound epoxy. No, I didn't drink fucking isopropyl. I wiped it on a napkin that I ate pizza off of earlier. Alright, we'll fucking try this again. Continuity test. Ground to ground. Grounds are good. Grounds are good to the jack. Let me plug this cable in. Make sure we're grounding all the way to the end. Okay, so something in the jack is not grounding the end of the cable. So it looks like both of these negative terminals need to be connected, which is like retarded. I don't know why that's a thing. Why have two? I'm just gonna bend them closer together and then solder them. For insulting me. Ugh. They don't bend easy. Alright, that's probably close enough. Do a little solder bridge across those, and hopefully it'll work now. Has anyone ever heard of that jack that requires both negative terminals to be hooked up in order for it to work? I don't know how. I don't know what's going on, why that's a thing. This is not the jack that comes in the kit, by the way. That one is way easier to use. 2 terminals, you fucking wire it up and it goes. You don't have to fuck with it. The 18650s will be good for digital if you put them in the 6-volt battery pack. So basically they have to be configured in a certain way for them to work properly. Alright. Got a nice solder bridge across there. And we can test continuity from the pin to the fucking end. Oh, I'm so tired of burning my hands. Alright. Boom. We now have continuity all the way out. For whatever reason, that pin maybe has some kind of resistance on that single ground, but it, ooh, what am I doing? I'm going to test continuity to the positive. We got nothing. We'll click the button. And we got... Seriously, nothing? What the fuck, man? Got positive at the jack. Where am I losing it? Where am I losing it? I know the buck had continuity, so I think it works. It's just probably just so much epoxy on all that shit in there that's just gumming everything up. So the only real thing to do is throw a tube in it and test. Right? That's the only thing we can do is put a tube in it. So we should just put a tube in it. Let me just figure out what way's on and which way's off, though, before we get to that point. Do a quick voltage test. See if we're actually getting voltage now. Zero volts. Nothing's getting hot, so hopefully nothing's dead. Still 0 volts. Fuck, dude, I'm tired of doing this shit. 0 volts. Alright, I'm fucking getting pissed because I know I tested these. 4 volts in, it's there. 3 volts. It's not outputting 3 volts. Is the buck dead? Because the buck is only outputting 2 volts and then it drops significantly. It just keeps dropping. Alright guys, check this out. When I check the buck output, that's what it does. Let me test this fucking buck and see if the buck is dead. Should have 0.552 ohms across those. I don't know what I could have did to break it. The only thing I'm thinking is that wet epoxy must be somewhat conductive. That's the only thing I can think of. Yep, we got the exact resistance we need, so the buck's fine. Oh my god, I'm fucking pissed. Alright, the board. For some reason, the board no longer has continuity of the buck. Whatever reason. So, looks like we're doing some fucking cleanup, even though we tested this and it worked. Fuck. We did test this, guys. I know we did. And I couldn't believe it. First try, the fucking buck was soldered on. So. Damn, this thing sucks. Crank the heat up. Crank it up. Get some hot solder in there. Ugh. Now we'll fucking test it again. Okay, continuity. It's there. Yeah, it's the pack's putting out 4 volts. Tested that. Continuity from tube to there. Continuity from tube to buck is good. Continuity from buck to battery pack is good. It's spotty because I can't get a good touch on it. Boom, it's there. Alright, everything says that. Why is there a click noise? That's what I'm not liking. Whenever I plug it in, I hear like a 2 voltage test. I don't even want to see what it says. You guys can see it. Oh! Look at that. Bad solder joint on the buck. We're rocking and rolling. Rocking in a rhythm, Bob Rand. Alright. Boom. We got our 3 volts into there now. Now, the only logical thing to do is take a Gen 3 military intensifier tube, like yay, expose it to some light, and then we'll drop it in. Get her nice and epoxy filled, Make sure she's got some epoxy on her. And check it out. Let me dim this so you can see. Boom! Night vision. Check the other side. Psh, it's fine. It'll be fine. You really want me to check the other side? I'll check the other side. Okay, the only thing wrong with the other side is this PCB fucking coming out. Bulging out of there from that epoxy. Boom! Got our tubes in. Now what do we do? Uh-oh! Why are we not powered on? What happened? Something happened. Alright. What the fuck happened? Just so you guys know, these are not good tubes. So, but it's really not that much money, I promise. This tube has a fucking line that goes straight across it. You can't even see. So, yeah, don't worry, guys. I'm not like throwing fucking real tubes in these things and fucking around. These are burner tubes specifically meant for this. All right, what did I do to fuck it up that quick? Got one from a guy on the Discord server for a little bit of money and some trade, and then got the other one off of Yield Facebook Marketplace for 450 bones. But it has a massive black spot right in the center. So like worst spot you can have, a blem, and it's huge. It's black, and it's fucking ginormous. Alright guys, what the fuck happened? I don't know what happened. We don't have voltage anymore. I didn't fuck with anything. Ugh. Continuity test, back at it. I'll unplug that. No resistance out there. Let's see. Alright, we're getting power to the buck. Now are we getting power out of the buck? Did that fucking solder joint somehow just shit its pants? Did this thing flop around too much? The world may never know. Is it the whole thing just stickier than hell? Literally just sticks to my hand. Can you hear this? Everything is sticky. I'm so tired of this housing. I will literally give this away. I do not care. If someone wants this, someone's gonna have this housing. That's a fact. So someone will be able to say, hey, I watched him totally fucking get super pissed building that housing. Alright, I got no continuity from fucking tube to the damn bridge. Alright, tube to there. Nothing from tube to board. Yo. For reals, dog? Ugh. It worked for like a second and then stopped working. You give your right toe for this housing? Look, dog, it's a freaking... This isn't even a nylon housing. This is carbon fiber PLA, not super strong. Like, it is strong, but it's not the strongest you can get. It's FDM. It's got some fucking shit in it. It's just a prototype housing I did specifically for this tutorial, and the reason it's camouflage is I recently multi-cammed an AR, and this was the test bed for the camo pattern. Alright, we'll make sure we get this fucker nice and hot again. We'll bring this magnifier over so I can actually see what's happening. I'm just gonna fucking stick her in the hole on the board, and hopefully it'll like solder itself. This shit is so hot. You don't even want to know. I don't know how this PLA fucking bridge is even together right now. Now what I'm doing is I'm just jumping back and forth, hoping that it's gonna either make a bridge or it's gonna solder them together. Ooh. I had them both at the same time. Alright. If this doesn't work, I'm literally just gonna like throw this housing out the window. Probably not. One of you guys can still have it, even if I throw it out the window. Continuity test. Oh my gosh, that's hot as fuck. Alright, what the fuck, man? Sometimes there's like a buildup of flux and whatnot on the ooh, that cut on my finger hurts, on the board, so you have to like scrape it and whatever to get a good continuity test. Damn, I'm fucking sick of doing this. Alright, absolutely unequivocally we do have continuity. Ground. We got resistance on ground now? What's this? Alright. We got ground. Ground is there. Woo. Alright. Now, it definitely should work this time. For sure. Like it did the last time, but only for a second. Which is weird. We'll plug our battery pack in. We'll switch to volts. Where do you get the STL files? Well, my friend, who's that, Rampart County? Yeah, I'm pretty sure you already bought them a while back, so, I mean, you do have them, but they will be released for free. Alright, we got our voltage, but what we also got is the fucking circuit board popping out again, because this stupid epoxy. Whose idea was this epoxy? It was mine. That's whose it was. I don't know what this thing's beeping about. Pretty sure the battery's gonna dead. Kobe, I can't promise you this housing. I don't know what I'm gonna do. Someone's gonna have this housing for free. Someone who was at the live stream. I'll just like roll through and pick someone at random. Hopefully it's someone who was here the whole time. Dedicated. You know what I'm talking about? Reward that dedication. I wonder if I can see who was here the entire time. And I'll like pick from those guys. Oh, my fingers are so sticky. Ugh. Alright, the only logical thing to do at this point is to finish building it. Just kidding. I'm gonna test the tubes again. Alright. Drop this ye old tube in. Boop. Well, I don't need no testers, but thanks, dog. I got plenty of testing to do. Alright, that tube should be seated as well. Dim the old light. Plug the old fuck stick in and we got one. Let me reseat this tube. Yeah. Make sure that one's in there properly. What? I got these from a lot of places, my guy. Alright, the fuck is going on here? Ugh. So sick of fucking doing this. Stay fucking put, yo. What are we on? Voltage test? Alright, voltage test this tube. We have voltage. There's a lot of epoxy on these fucking terminals from that stupid potting compound. I'm gonna put a glove on and I'm just gonna get in there with a freaking paper towel and just isopropyl all the shit out of them. Look, guys, if I knew that epoxy was 70 minutes before I poured it, I would not have fucking used that. I would have used the 5-minute stuff. This is gay. I'm just like gently trying to rub any epoxy off of those contacts to make sure it gets a solid connection on the tube. $70 yeah, I'd say we're past 70 minutes too. So I'd like to know why these motherfuckers lied and said it's a 70-minute epoxy when it's fucking still gooey and fucking gross. And I hate it with a passion. Hey dude, I had gloves. They got gay and sweaty, so I took them off. Alright. It's a little crooked. Voltage, 3 volts. We'll switch it around so it actually looks right. Oh, I just smeared epoxy on that pin. There's a nice gloopy gobbly gloop of it in there. This was such a terrible mess. Yeah, dude, it's sticking out enough. It's just, I think it's just got so much crud on it. So, I want to see. There it is. They're not supposed to be symmetrical just because the way the tubes are. But, yeah, man, I'm fucking... Ugh. Stay away from the potting compound shit because that stuff takes a hot minute to dry. Alright, we'll drop this tube in here. Make sure I got my positives lined up. There's like something sticking in there kinda, and I think it's a nice glob of epoxy that's like somewhat cured. Ooh, Let's unplug it. I can hear the auto gain going. It's always good. See what we got. Boom! Wait. Oh, this isn't a bad tube. Shit. This is a good tube. This is a good tube over here. We don't want to ruin that one. How'd I get those mixed up? Where'd the bad tube go? Whoops. Alright. You can get the entire parts kit on the website. Comes with all the hardware. There's options to buy the lenses, options to include MJF housings. So, yeah, it's all there. It's not the cheapest right now, but I'm going to do away with the regulated boards on my file, or on the website, and they're going to be unregulated boards that are meant to be used with this battery pack, which outputs 4 volts for fully charged 18650s. It's still a good tube. It's got a minor blem, zone 3, so it's all right, but yeah, it's still a good tube. Will I have a built kit or build kit? I do plan to have some built MX69s. The plan is to have them aluminum because I think I really wanted to get the aluminum ones to work because it's going to be a nice heat sink to pull some of that heat off the CMOS and hopefully give you less noise in the picture. I've been brainstorming a way to like incorporate some heat pipes into the design to like actually suck the heat out of the housing itself, but the housing wall is only 1 millimeter at its thinnest point, so that should be enough to let some of that heat dissipate, and this will just act as a giant heat sink for the digital tube. MX69 is the digital tube, so this is the MX69 printed housing. You put your camera in the front, your display, your board, everything goes in here, the voltage regulator, and then the plan was to just fill this sucker with potting compound, but after 70-minute dry time and a gloopity fucking gobble goop mess, I don't know if I want to do that again. Chill, dog. I'll get you the STLs. They'll be available tonight. The IMX cams. So actually the run cams do use IMX sensors, but I think I know what you're talking about, those new IMX ones that we're discussing in the Discord. So we're looking at a couple different cameras. The issue is we need them to output CVBS or analog signal, so we can use that because that's the fastest signal type. It's faster than digital signal because it's literally the speed of light. So that's why the PVS-69s can have such low latency compared to Psionics, because we're using a different video signal that is way faster because it's just pulses of light to create the video signal. Like pulses of electricity that's just transferred from light. I don't know. It's the fastest, okay? That's all I know. But anyways, we're looking at some CVBS cams. We want to get the IMX 462 because that is the best camera that Sony has. The problem is like nobody makes it, even though it's supposedly the same exact pinout as the IMX 290, which a lot of people make. So trying to be able to finagle some of them Alibaba sellers to get us some IMX 462 cameras in monochrome, because monochrome is actually, I think they claim to be 2 times better, but in theory, I think it could actually be 3 times better than a color camera because it doesn't have the light filters on the sensor itself to block out red and blue, or red, blue, green, RGB, whatever. RGB colors for different pixels, because that's how it actually determines the color. But yeah, we're hoping to get that worked out. All right, back to Millie Josh's comment. The MX69 is a digital tube. It could potentially work in other housings. The difference is the MX69 takes this objective lens, which is got some printed parts on it to make it work. But basically, it also needs this. I'm going to call this the retainer. And this retainer has a thread pattern that's on the end of the PVS-69, but that's not the same pattern from conventional tubes. So I would need to redesign this with whatever thread pitch / pattern is on the end of regular like PVS-14s or whatever Anvis is. J Wolf, for the build price, you can build an entire alpha housing with digital tubes for around $700. I want to say under, but I don't know if you could really get it under 700, but you could build it for around 700. That being said, the housing itself, you could get that for, you could build it for like $100, but then you still got to source lenses. I mean, like, you get my part kit for 75, right? And then you print your own housing. Like, for it takes less than a spool, obviously, so another $20 in filament, and you have a complete housing for under $100. You can order the housings. You can get them from me, MJF printed, or you can order them, whatever you want to do. But you can get a very cheap housing that's actually really good. Like, this is a pretty freaking sexy housing, if I do say so myself. Yeah, for fairly freaking cheap. So get after it, I guess. MJF is like, this is the raffle set right here. This is an MJF printed. I got some purple filters on there. Basically, regular printing stacks layers, and those layers have weak points in them. MJF does not have those stacked layer weak points. It's just a solid piece of material, so it has that isotropic properties where it's basically the same strength throughout the entire piece, making it super freaking solid. Yeah, dude, these things are sexy as fuck. Something that I'm super proud of is these detents. Check this out. It's got a detent, boom, snaps into place, and it's like locked right there. Whereas if it's like free moving, you can kind of like swing it around. But you detent it up, and there's two detents. It's first click and second click. So first click stows them like parallel, second click stows them up. So you can stow these, and it's super dope. These ones got Carson lenses in them. They got white filters. There's a tiny, tiny blem in zone 3 on this tube. And the other tube is like fucking crystal clear. And yeah, these things are pretty fucking dope. You could have it for as little as $10. So get after that. What's the name of the website? It's VonScherfArms.com or VonScherfArms.company.site, whatever you want. Both should work. Anyways, back to the fucking build, because we're getting way off of track here. I'm gonna poke this. Wait, I was gonna make this a goopy mess even more. I forgot. You guys distracted me. I'm gonna run this through here. I'm gonna heat shrink the connector, and then I'm gonna fill this sucker with fucking potting compound. Oh no, I never put these heat shrinks on. I put them on the wire, I didn't slide them onto the terminal, guys. Fuck. Take the tube out for the epoxy sets. Nah, I'll leave it in there. It'll help it set better. It'll help it set in place where it needs to be. They're not gonna get ruined by it, so it's fine. If they do, I'll just scrape off the epoxy. Tubes are pretty versatile. make the housing out of, dude, I like that. We could just like, dude, I could like make a 3D printed like injection mold, and we just inject it with potting compound, and boom, housing. And then we just have to like sit and spend hours breaking the printed mold off of the potting compound. That's a solid idea right there. I like that. That's a total joke. I am not doing that. Fuck that. I'm probably literally never going to use potting compound again after this. I'm just going to go back to the 5-minute epoxy. So, something I do have is I have like tubes for the way this potting compound comes. It's in like 2-part tube. I have empty tubes that I was going to fill with Harbor Freight epoxy and use those to do potting, which is probably a much better idea. Should I do that right now? I feel like I should do that, because fuck this thing. We're gonna use 5-minute epoxy to do this potting. All right, boom. Part 1, part 2. Hey, we're actually getting some more freaking guys in here. What's up, guys? 38. 38, Doug. Let me put a cap on this before I just start squeezing epoxy into it. How do these caps go on? I don't know how the cap goes on. There we go. Never done this before, guys, but when in Rome, get the dome. All right. One type goes in one side. What way does that go? Give me a sec. Don't know what way the plunger goes in, so we'll guess. All right, one side's in. Now for the other side. Ooh. And we don't have to worry about the ratio because the gun and the mixing tube do it all. They do a nice 1-to-1 mix ratio, so you can like get more on one side than the other side, and it'll just mix it for you. So here we go. Boom. Those are on there. And here's the old tube that we used. Oop, plunger's coming out. Potting compound, fuck potting compound. No, does not come in the hardware kit. Get fucked. Is that a joke? I hope that's a joke. Alright, I'm just gonna squeeze out all the black shit into my garbage. Oh, it cured in the tip of the fucking potting compound. Oh my gosh, that's a terrible mess. This was a terrible idea. Potting compound on everything. On my multicam chair. Alright, new tip. What am I doing with this? Why is it black? Should not be black. Alright, I have no clue why this is black. Oh. Sorry, Kobe. Right? Yeah. I'll pot the shit out of this bitch. Alright, that's gonna be a mess in like 30 seconds, so. Don't ask me why it's fucking black. I have no clue. Oh my gosh, dude. Epoxy is such a fucker. Guys, you do not need to use epoxy like this on your builds. Just saying. I'm a friggin' dumb fucker. You know what? For good measure, we'll squirt a little 5-minute epoxy in here. Make sure everything's solid in there. We'll do a little in there. A little in there. This whole thing's gonna be just epoxied shut. It is not leaking. Yo, this thing is not leaking. Oh my gosh. Alright guys, when you do your build, don't use this much fucking epoxy on everything, because I'm doing it because it's funny. I need something to pack these wires in. Oh my gosh. Get in my belly. Get in there. Oh my gosh. Get in there. This is so fucking messy. Holy shit. It's like not even like together. Oh, there we go. What we got going on? Get in there. Uh-oh, the button stopped working. Stupid wire. There's like one wire that's getting pinched instead of going together. There's something's fucking going on. What the fuck? Well, when in doubt, fucking run a damn bolt through it and call it good. I'll do this side since that thing is broken in there. I'm just gonna crank her down. Call her good. Fill the gaps in with epoxy. This is not how you should build these guys. Please don't fucking copy this. I have no clue why it's not fucking snapping together like it did before I put all this epoxy on it. And this bolt isn't fucking going through. Probably because of potting compound in there. You know, I think it does need more, actually. No, I think there's actually hardened potting compound in the way of this bolt that we're in now. Yeah, dude, that's awesome, actually. I didn't even think about that. Now when I do the tutorial, I can say, hey, if you watch the live stream, don't do any of that. Don't do it that bad. Where is the wire getting pinched? There's a wire getting pinched somewhere, and I can't see where because of all the fucking epoxy. Jesus Christ. Like, what is this gap? Holy shit. Alright, here's what we'll do. We'll thread it, start threading it, and see if it'll just pull itself together. It's kind of working. Yeah, see, that epoxy, I thought it would kind of lubricate it, but it's actually hard now. So my fingers are hard, the housing is hard, everything is hard. I don't have a socket or anything that fits these fucking nuts. But I got pliers. You were late on that one for sure. For whatever reason, this housing said it did not want to go together, so. I'm gonna take some isopropyl alcohol, try and de-tackify this thing a little bit, because it's so sticky. I thought it was sticky with the potting compound. Boy, I was fucking wrong. Try 5-minute epoxy on everything. Probably not even gonna screw together the rest of the way because it's hard now. The epoxy's hard for sure. Hey, one thing though, I did coat a PLA Glock frame in countertop epoxy. It's like 24-hour curing stuff, and that shit held up for like 200 rounds. Printed the exact same G code, same exactly the same, identical to it. Oh fuck! And it only lasted like 5 rounds. So there is something to be said about epoxy coating your print. I'm missing a bolt. I'm so tired. I just want to get this done. That's why I'm rushing like this. I didn't even put the heat sets in. We'll worry about that on another live stream. Just kidding. This bolt hole's like clogged up. Oh my gosh. All right, that's not good. I don't want to have to like drill this out because then I'm gonna fuck the wires up in there. But that is solid with epoxy. That should have some better foresight there. Oh my god. Oh my gosh, my fucking screwdriver's falling apart and everything. I think we're thread through the mostly hard epoxy. But that bolt has to be going straight or else it's not gonna thread into the bridge properly. Kobe, how'd your name change color? I feel like it was orange before. Fuck. Oh no, I just bent this fucking bolt. So much for stainless steel. That's gay as fuck. Damn. Let's try going from this side first. See if we can't punch some of that epoxy out of the way. Because it is solid. That shit solidified. And I'm sure it like is like fiber reinforced with the paracord stuff that's in there. Oh. I don't know if you guys saw that, but the bridge was just fucked. All right, got the last bolt. This thing is so sticky, you guys have no idea. Oh, where's that little fucking piece? I'm so tired. Fucking A, man. Where the fuck is everything? Everything's gone. Alright, here's the nut we need. Now where's the fucking cone washer? Alright, cone washer. I have not been paying attention to comments, guys. I'm sorry. I'm not going to say it again. Sorry, dude. Analog build price, it's really going to depend on tubes, what tubes you are willing to get. The dovetail can go in last. It's meant to be like a replaceable part, so. Alright. Oh, yeah. We'll just keep her moving for now. Keep her moving. Yep. On these? On right here? Or on this one? I'm just kidding. Oh, that's solid. That's a solid chunk of epoxy right there. Yeah, who needs detents? Who needs articulating night vision? Just hold it down and let the epoxy dry. I'm gonna just soak this whole thing in alcohol. Should I just go run this sucker under the sink real quick? Maybe that'll help the epoxy go away. That's a joke. I do not want to do that. Hey, the button is still flexy. Psh, it don't matter. Obviously, it's not good for me to be touching this or waving it at the light, but it don't matter, dude. This tube has hit its last owner, and this thing, I'm gonna be like whistling Diesel with night vision. Just fucking destroy beautiful tubes for your guys' enjoyment and for you guys to hate on me. The epoxy 69s, hey dude, you want these ones? I'm gonna give these ones away to somebody. And they're actually in for luck, because I'm gonna make sure they're all cleaned up and nice, and they're gonna have like the most rigid pair of PLA PVS-69s. Yeah, Quack ordered some aluminum dovetails. I don't really think it's necessary. I updated the dovetail design. It's got more surface area, layer-wise, so it's like better, I guess. Yeah. Let's see, do I still have those heat sets? This is probably not going to go as planned. Oh, wait, actually, I'm going to clean the solder off of that before I fucking solder the damn heat set to the iron. Ooh, that's hot. Oh no, fuck. Hey, that's a good idea. To epoxy it before I do it all. But how does that add to the fun? No, basically what happened was I tried to do something new based on, instead of what I normally do is I put the tubes in, and I take these, or I take like a printed version of these, and I put them in there to hold the tube PCBs in, and I just fill that with 5-minute epoxy, and it doesn't glob out and pour out the front like it was doing, and then it's like a nice solid connection in here for that tube PCB. It seals it off so nothing can pass through here except for the wires that are going through there. And then I've never epoxied in the bridge before. This is my first time doing that, and that just turned into a mess because it just poured out everywhere. So yeah, this whole thing was kind of a fucked up situation. Potting compound the heat set. No thanks. I put the heat set in. Now I gotta do 2 more heat sets. Oh, that's scary. I feel like I'm gonna snap it every time I do that. For the IPD stops. Get off of there. Oh, dude, you could do this definitely without the fucking epoxy. It kind of just turned into a meme, so that's why I was doing it. Oh. A little bit of a gap here, but nothing. We can't suck it tight. We want to pull the bolt through, but see if we can make it a little tighter. Yep, that's as tight as she's gonna get. Nice and epoxied. Where'd I get the tubes? Discord, Facebook. You can get them lots of places. These housings I'm gonna give away to somebody, so just like, if you're watching this and you haven't commented, comment, because I'm probably just gonna pick a random comment and, like, I don't know, if you get a reply from me on that comment that says, hey, you got these tubes or whatever, yeah, or not tubes, you're not getting the tubes. Fuck you guys, you're not getting the tubes. I'm already giving away tubes. I'm giving away these housings. So. You're not getting tubes, fuck you. I'm already giving away tubes pretty much. Alright, fuck. Damn, I do not want to put my epoxy ass hand on that tube to push it back out. I wonder if those set up yet. This tube just wasn't seated in there, so I'm gonna just seat it properly. Oh, why is this one so sticky? Not like sticky like there's epoxy in there, like sticky like it's not sized properly. I think I got too much spray paint in this tube, and it's just a tight squeeze. Alright, I think that's in there. Maybe. Alright, that's probably in there. Now, we're gonna finish this build up. Got our lenses. Ooh. Fucking A. Oh. We got our tube retainers. We got our infinity stop rings, first step tube retainers. This tube does not look like it's seated properly. So let me test it, make sure it turns on. Ooh, the jack barely fits in there now because it's got so much epoxy on it. Oh, what the fuck is the cable? Oh, the cable must have got dripped on. Came through dripping. Well, one tube's on, the other tube isn't. That's not fun. Oh, the other tube's stuck. All right, guys, we epoxied this tube in place. Fuck. Oh, that's shitty. Ooh, yep. That tube is in there. That ain't coming out. Oh, this is so gay. And not only that, it doesn't work. So this one's on, that one's not. So it's stuck and it's not working. Oh my god. All right, guys, I'm ready to call it for the night. I'm fucking tired. I've been at this for hours. Ugh. Damn. Alright, I'm gonna pull the good tube out so we don't epoxy that one in place. And then I'm gonna do something crazy. I'm gonna take this pick, I'm gonna wedge it between the tube and the housing. Ooh, that sucker's in there, yo. It's moving. It's moving. It's gummy, but it's moving. Oh, I don't really like to push on this thing. It's moving. It is moving. It's really bad for a tube to apply pressure on the front of it. So I'm really trying to be careful with this because even though it is a bad tube, I don't want to destroy it because I still use it. Oh, dude, those objective lenses are not going to thread in here because there is potting compound in the threads. Ah, fuck me. What if I just do this? It's not sealed. It helped. It helped. Ugh. Yeah. Yep. There's a problem right there. Got a little epoxy on the tube. It literally epoxied the contact. Oh. Oh no. That's worst case scenario right there. So we got a nice clump of epoxy on contact in there. It's still somewhat malleable, so we'll see if we can't just bust it off. It's about the consistency of dried hot glue. But what we don't want to do is accidentally tear the positive contact out or bend it too far out of shape, which we did. Positive contact is fucked. The other side turned out kind of fine. Nothing really leaked through. This one got pretty fucked up. So I think that tube wasn't working. It's probably the epoxy somehow got between the tube and the contact. Because the whole contact was just coated in epoxy. It still is. The positive contact just has a nice layer of epoxy on it. I'm going to clean this real quick. Yeah, great engineering lesson on epoxy. It sucks. It's sticky. All right. Hey, brother. Night vision is taking years of my life, so. Tube test. Oh, it's backwards. How'd I do that? I'm tired, guys. I'm tired. Oh. Damn ass. Alright, that's a good, solid seat. Tube's on, boys. Surf's up. But this wasn't the side it was originally in. So we're going to put it back in its original side where it got stuck in place. Let's see if it works over there. Oh, it doesn't work. That's gay. Well, guys, I'm fucking sick of this. I'm gonna do one last continuity test. We do not have continuity across the tubes. This tube lost continuity on the positive contact, so that is probably going to be a wrap for the night. I'll clean it up quick, fine. Jesus Christ. Since you begged me to. I've been up for so long. I still gotta go release the damn alpha files for all you squebs out there. Just kidding, you're not squebs. I don't even know what that is, I made that up. Yo. Oh. Negative contact broke off of this side. And that was the good side. Fuck! I don't even know how that happened. Here it is, though. Hey, dude, don't judge. Because guess what? We're ending this shit right now. I'm done. That's how you build it. Don't do the epoxy part and it'll go fine. Who wants this housing? Leave a comment if you want this fucking housing. It's got all the parts you need. I'll throw in the fucking extra little shits. You're gonna have to break it apart to get it to work. Alright, guys. Oh, man, I'm fucking tired. I will see you next time. Yeah. If y'all aren't in the Discord, hop in the Discord, comment your Discord name, and I'll pick someone out of the Discord to win it. How about that? So you gotta be in the Discord. Discord's where it's at. But yeah, that's it. That's the build. It's supposed to go way easier than that. Don't use potting compound at the start because that'll just fuck you. There's the dovetail. And we'll put the bolt in the dovetail just to fucking finish it up. Not the right size. Alright, y'all. I'm gonna end the live stream probably like a minute. I just gotta fucking, for the sake of it, tighten this fucking bolt in. Even though this housing's trash. I hate my life. I'm so fucking tired. I wanna go to bed. Ooh, that's it, guys. Good night. Super fun building this with you. Super fun. How do I end this fucking shit? Don't use epoxy. Fuck epoxy. That was sucked. That was terrible. If you're going to use epoxy, use it, let it sit. Don't do it on a live stream. Peace.